the first day is more of an introduction to ExactFlat and a discussion of its options and configurations. And the second day is about the database manager, and to do the, I talk about requirements and best practices. The first item is when importing non-native documents, the import feature must be dissolved and the document must be saved as a SolidWorks part file. Once you've saved it, close your document and reopen the SolidWorks part file. So if I were to bring in something like a step file, let's see if I can find the step file here, you're going to notice there's a step file right here. When I bring this in, and there's the import feature right here, you have to break the link. Once you break the link, just go to File, Save As, and save it as a new SolidWorks part file. You can then close this document and open up the new part file that you saved. If you don't do that, none of the ExactFlat seam features or the grid in the background, you're not going to be able to see any of those. So it's very important that you break the link. The next item is once you've started using the piece creator, you can't make any kind of changes to the 3D model. So the piece creator will effectively lock the 3D model into place. If you do realize that you've made a mistake, or you need to add a cut line or a dart, or you need to change the shape of a face or scale your model, you need to basically remove the piece creator from the document. That will effectively undo all of your flattening and patterning work. You can then make a change to your 3D model, and then you can restart the flattening process starting with the piece creator. The third item is once you have formed pattern pieces with the piece creator, and once you have converted that document to an ExactFlat document, you can no longer make changes to the piece creator. So if during your flattening process you realize that there's a hole in your part, there's a face that is missing that you forgot to select, or if you have extra faces that are not supposed to be there, you need to effectively undo the flattening process by going to Insert Tools or Insert ExactFlat, Revert to SolidWorks Part, and that will undo the flattening process, giving you full access to the edit features of the piece creator. Once you've done that, you can then open up the piece creator and you can modify your part and add the missing face, remove the missing face, add the missing piece, or remove the missing piece, whatever you need to do. Fourth, pattern pieces cannot be moved or modified after a grain line has been added. So once the grain line feature has been added to your pattern pieces, the only thing you can do from there is export your pattern pieces to DXF. If you try to move your pieces, in most cases SolidWorks is going to crash. So it's very important that you save your grain line to be the very last step of your workflow. Otherwise, you're going to get unexpected behavior, which will probably ultimately lead to SolidWorks crashing. Lastly, all model edges need to be watertight, and all intersecting edges must share a common vertex. So as we look at this model here, we can see that there's no gaps or holes between any of the edges. And if we start examining the edges here, we can see that they're all intersecting at a common vertex right there. So that's what we want to see. We don't want to see a vertex somewhere placed in the middle of a very long edge. If you do that downstream, once you start adding seams and hems, your seams aren't going to align, your notches aren't going to align, and you're not going to end up with a good pattern. So just make sure that your part is watertight, and that there's no holes or gaps between your edges, and that where you do have splits or breaks in your edge, that they occur on both sides, all shared faces of that edge. So as long as you keep those requirements and best practices in mind, ExactFlat is a very powerful tool that will allow you to very quickly flatten your parts and do your patterning work. So today we are going to focus on the standard ExactFlat workflow. We are going to examine each aspect of the workflow and discuss it in detail. And we are ultimately going to apply that workflow to this chair here. and I will show you how we can take this 3D model of a chair and produce a 2D flat pattern and a drawing document for this particular chair. So we're going to start with the ExactFlat piece creator. Once this is open, we have our main input box, and this is where we can start adding faces. So as we look at this chair here, we've got multiple faces color-coded in yellow for the backrest. We've got a couple in magenta for the seat, and the sides of the chair also have multiple colored faces. So each color represents our ideal piece of fabric to use as a pattern piece. So with the piece creator, what we can do is we can just simply start selecting faces here, and this will allow us to effectively knit these together. So internally, we're just using the SolidWorks knit surface feature to knit all of these faces together. As we start picking faces, we're going to notice there is a red arrow emanating from the pattern pieces. This red arrow indicates the facing up direction of your pattern piece. So if this fabric were to be laying down on a cutting table, this red arrow would be pointing up towards the ceiling. Because this is the finished side of the pattern piece here, this is the side that we actually want facing up towards the ceiling. So all we do is we just click on the red arrow, and that will flip the orientation of the pattern piece. Once you have your faces selected, you can click the Create Piece button, and this will create your pattern piece. So now down here in the Piece Manager, we have a new piece. Piece number 1 has been added to the Piece Manager. We can continue carrying on, selecting additional faces, and as I select additional faces, once again, we have that red arrow emanating from the piece. And again, this is in the wrong direction. So we're just going to click on the arrow, and that will flip the orientation of the pattern piece. If you're noticing that every single pattern piece is being created with an incorrect orientation, you can change the default piece orientation option up here from normal to flipped, and that will automatically flip every single piece orientation as you start creating the pattern piece. So we have our 2 faces selected, so we will go ahead and click the Create Piece button here to create a new piece in the Piece Manager. You can also use the Enter key on your keyboard to quickly add pieces to the Piece Manager. So once you've selected all your pieces, you can just press Enter, and that will very quickly do the same thing as clicking the Create Pieces button. As we add our pieces, we will also notice that the pieces are automatically being named for us. They're being named in sequential numbers. This name is being generated from the ExactFlat options. You have quite a bit of control over how your pieces are being named, so you can change the template and the format of this name to include things such as file name or the body name, or even SolidWorks custom properties. And we will look at that in a bit more detail tomorrow when we talk about the ExactFlat options and the ExactFlat database manager. If we want to change this name at any time, we can do so either after the piece has been created or while the piece is being created. So for this piece here, if we wanted to give it a more meaningful name, we can simply change the name to whatever we want. So for this piece here, I'm going to call it Inside Right. And because we haven't actually created it yet, we'll go ahead, we'll press Enter on our keyboard to create the piece. We'll go back to these 2 pieces here, and we'll rename these pieces so they're a little more meaningful. So we just select the piece in the Piece Manager, we bring our cursor up here, and we change the name of the piece. And we'll do the same thing for this one. And we'll finish creating our pieces here. Once your pieces have been created, we can click the green check mark here, and that will close the PMP and insert the Piece Creator feature into the feature tree. This is a good point in the workflow to examine your model. You want to make sure that there aren't any holes or gaps, and if we look in the feature tree here, specifically the surface body folder, we can see the results of the knit surface feature. Every single piece has now been created as a separate surface body. So we can select each surface body one at a time, and we can just rotate around to make sure that we don't have any extra faces included in our surface body, and to make sure that there aren't any holes or gaps in the surface body. So it looks like our selections are all good. If we did notice an issue with the piece selection, we can always go back to the Create Pieces button. We can open up the piece creator again, and we have full access to our pattern pieces. So if, for instance, we realize that we no longer need the seat here, we can simply select the seat from the piece manager, and we can dissolve that part, and that effectively removes it from the piece creator. If we realize that we forgot to add a part, or if we forgot to include a face in a part, we can simply select that part. So for now, we'll add the seat pieces to the inside pieces. So we can select a piece here, we can edit that piece, and now we can either remove the undesired face by holding Control and clicking on it, or we can add additional faces by simply selecting them. Once we've made our change, click the Update Piece button to save changes. We don't actually want to join these two pieces together though, so I'm going to once again edit my piece, and I'm going to remove that face and update my piece. Similarly, if we forgot to add pieces, we can just create a new piece by selecting the faces, give it a name, and click the Create Piece button. We can now close the piece creator and accept changes, and all of our pieces are formed. After we have finished with piece creator, we can now start the flattening process. The entry point to the flattening process is the Convert to ExactFlat button. Just a reminder, once we click the Convert to ExactFlat button, we will no longer have access to the piece creator. We will not be able to modify our pieces or add or remove faces. So make sure that your model is accurate and complete at this point, and then we can move on to Convert to ExactFlat. So once we're happy with our model, click the Convert to ExactFlat button, and this will start the conversion process. The conversion process will first create a mesh from our model for flattening, and lastly we will assign a material to each piece that we have defined with the piece creator. ExactFlat is a two-stage flattener, so we do our flattening in two separate steps. The first step is a very fast pre-flattener that is applied to the mesh created by SolidWorks. And the second stage is the optimizer, where we use the mechanical properties of the material to relax the curvature and the average energy density of the mesh to as close to zero as possible. The second stage flattening does use the mechanical properties of the material, so that's why we're being asked to pick a material at this point. In addition to setting up the flattener, materials are also used to set up your markers. So each material not only contains a name and description, but it contains the mechanical properties for flattening, as well as the dimensions of the material for nesting. So from the material selection, we can pick we can assign one single material to every single piece, or if your part is designed with multiple materials, we can pick individual pieces here, and we can assign different materials to different pattern pieces. So you can assign as many materials as you want to your different pattern pieces. The only important thing here is that we do assign a material to every single pattern piece. So for this particular model, we're just going to assign laminate for car seats to every single piece here, and we will go ahead and click OK. After the conversion process, we have our chair, and we can see that the color has changed to pink. So pink is the color associated with the material we selected. If we had selected multiple materials, then we would have seen multiple colors on the car seat, and each pattern piece is color-coded for the specific material that was selected for it. Once the conversion process is done, we now have access to the flattener and the View Patterns buttons. So now we're going to click View Patterns, and this is going to bring us to our 2D flat patterns. From here, we can see the initial unoptimized 2D flat patterns. As I mentioned previously, ExactFlat is a two-stage flattener, so the results we are looking at are simply the results of one of our pre-flatteners. We haven't finished the flattening process. We still need to optimize the shape of our pattern pieces. To do this, we are going to open up the ExactFlat flattener. And once open, we have access to all of ExactFlat's flattening controls. The flattening interface is divided into three main areas. At the top, we have our model and pattern viewports. The controls in the viewports are exactly the same as in SolidWorks. So we can orbit around our model by holding middle mouse button and dragging our mouse. We can zoom in and out by holding Shift and using our mouse up and down. And we can pan around by holding Control and pressing middle mouse button to pan around our object. The controls are exactly the same in the pattern viewport, with the only difference being we can't orbit around our objects. The pattern viewport is locked to an orthographic projection, but we can still zoom in and out, and we can still pan our camera. Below the viewports, we have our toolbar. On the left, we have our flattening controls, and on the right, we have our highlights, where we can turn on or off different visual cues. And below that, we have our pattern piece list. Whenever we click any of the controls, the flattening controls, that operation is going to be applied to whichever pattern piece is selected down here. So by default, every single pattern piece is selected. However, if we only want to apply an algorithm to a very specific pattern piece, we can single that piece out, or we can select multiple pattern pieces. We do have multiple highlights that can be turned on or off, and the multiple highlights can be used for many different things. Starting with the first highlight here, this is our piece normal. We can use this to show the normal direction of the pattern pieces, and this is functionally equivalent to the arrow that we saw in the piece creator. If we turn this on, we will see little red line or little black lines emanating from the pattern piece, and these emanate and point out towards the facing up direction. So in most cases, you want these lines coming out of your pattern piece. You don't want them going towards the inside. If you see those black lines on the inside of the pattern piece, usually it means your face normal has been reversed, in which case you're going to have to undo the flattening process and then fix your piece orientation in the flattening window. The second option here will turn off flat shading, so it will introduce lighting into our document. In most cases, it just makes our model look gray, so it's not a very useful option, so we're going to turn this off. Our third option will turn on or off the edge triangulation, and this is useful if we are trying to examine the strain of the model. It's often easier to examine the strain of the model without the triangulation visible. We can also use the edge highlight. We can turn it off to make it easier to spot folds and wrinkles in our pattern. So if we look at this piece over here, this would be a good example of a pattern piece with folds and wrinkles. Whenever we see these green crosses and inset triangles, that's an indication that we have a fold or a wrinkle in our pattern piece. The fourth option is the wrinkle highlight. We don't ever recommend that you turn this off. If you turn it off, it simply hides the folds or wrinkles. But because folds and wrinkles are considered to be patterning errors, it is not recommended to turn that off. The last option here is the strain map. If we turn this off, we no longer see the strain map on the pattern piece, but it's very useful to turn that off if you're looking for folds and wrinkles. They're very obvious on this piece here, but if our pattern only had one small fold or wrinkle, then turning off the edge highlight, turning off the strain map will make it very easy to pick that out and spot the fold or wrinkle. So we are going to turn back on the strain map, and we are going to turn on our edge highlight. Moving on to the flattening controls. Our first group of buttons here are our pre-flatteners. Starting from left to right, we have our Smart Fracture Pre-flattener, we have our Fracture Pre-flattener, we have Stretch Initial, we have Stretch Minimal or De-wrinkle, and we have Stretch Round, and lastly we have Pelt. The pre-flatteners are simply 2D algorithms used to take the 3D shape of the mesh and generate any kind of 2D flat pattern. The flat pattern created by the pre-flatteners is not an optimized flat pattern. However, they are very fast and they're used to generate A, a 2D flat pattern, and B, hopefully a flat pattern that doesn't have any folds or wrinkles. We have many different algorithms because the different algorithms work better on certain types of geometry. And because of the nature of folds and wrinkles, if one algorithm produces a fold or wrinkle, you can then try a different algorithm to try and produce another flat pattern that doesn't have any folds or wrinkles. Starting with fracture, every time you click the fracture button, we will generate a new unique flat pattern. So we're going to isolate on the backrest here, and we'll look at the effects of the pre-flatteners on this particular part here. Every time I click the fracture button, we're going to see a new unique 2D flat pattern being generated. In this case, we've got fairly low strain spread out through the part, and we don't see any folds or wrinkles. The starting point for fracture is always randomized, and as we fracture a part, we're actually pushing the material outwards from the starting point. So every time I press this button here, we are randomly picking a new starting edge, and we're going to be pushing the material outwards from that starting point. Fracture is very similar to this. It doesn't have the same built-in intelligence that smart fracture does, so it tends to produce patterns that have more folds and wrinkles, whereas smart fracture, when it detects a fold or wrinkle, it will attempt to correct that and then finish its algorithm. Our stretch initial algorithm works very well on pattern pieces that are comprised of 1,000 vertices or fewer. However, once we have more than 1,000 vertices, the results become unpredictable, and we typically start to see this type of result here. De-wrinkle works very well when we have a pattern piece with a shape that is very ideal, such as this, but we have a few folds or wrinkles in it. It is similar to the stretch initial, so just like stretch initial, it works really well on pattern pieces under 1,000 vertices. But once we have more than 1,000 vertices, the results become unpredictable. So we'll try de-wrinkle on this piece here, and in this case, it removed most of the folds or wrinkles, but it still produced this spike down here, which is not ideal. Our round algorithm does exactly what it sounds. For this one, we will move to one of the side pieces here. They have fewer vertices. So this basically turns your pattern piece into a disc. It's not very useful for this type of shape. However, if we were flattening something like a dome, then this algorithm would become very useful. If all else fails, if every single algorithm fails to produce a pattern free of folds and wrinkles, then round can be used. It might take a little bit longer to optimize, but the important thing is that we don't have any folds or wrinkles when we start the optimization process. So round can be used to get a pattern if no other algorithm is going to succeed. Moving back to our backrest, our last algorithm is pelt. And this algorithm tends to produce patterns that have moderate strain, but it is almost always guaranteed. So fracture and smart fracture, they tend to reduce or give patterns that have the least amount of strain, but they tend to only work on developable surfaces. As you move away from a developable surface, the chance of success with fracture and smart fracture starts to fall. CCM, or stretch initial, de-wrinkle, and round, they only work really well on low vertex count pattern pieces. As soon as you get more than 1,000 vertices, they tend to fail. And then the last one is pelt, which tends to work well on all pattern pieces. However, it tends to produce more strain. So strain is calculated for every single pattern piece, and as we look at our pattern piece here, we can see different colors on it. If we look at our model as a whole, we can see a rainbow of different colors, and we actually use the color to represent strain and sag on the pattern pieces. As we look at our pieces here, we can see we have white, cyan, green, yellow, and red, and we use white to indicate no strain or sag on the pattern piece. So if we had the perfect pattern, we would expect to see the entire surface area of the pattern as white. As we move through the spectrum, cyan represents up to 10% strain. So, up to 5% strain. Green is up to 10%, yellow is up to 15%, and red is 20% or more. So this allows us to just very quickly glance at our pattern, and we can just visually tell how much strain is on that pattern. To put this into perspective, strain can best be thought of as how much you're going to have to stretch your material to get it to fit the original shape. So if we look at this piece over here, we have a lot of red on the pattern piece, and that's telling me that the surface area of this section of the piece is much smaller than the actual 3D model. The surface area of the 2D pattern piece is much smaller than the surface area of the 3D model. So if we were to cut this pattern piece out and try and fit it to the chair here, we'd be stretching our material 20% or more to get it to fit, and ultimately we'd probably tear the material. So we can use the strain map to very quickly tell us how accurate our pattern is, what the quality of the pattern is. Similarly, the seat pattern right here, it's pretty much all white. So if we were to cut this out, visually this tells me that we'd have pretty much a perfect fit here. We wouldn't have to stretch our material to get it to fit. It would be a very natural fit. So with all this in mind, our goal is to eventually optimize our pattern pieces to give us our final optimized shapes. In order to do this, we first need to use a pre-flattener to generate some kind of 2D flat pattern, and this is in most cases done automatically for you during the conversion process. However, if you have folds and wrinkles here, these do need to be fixed before we can optimize. So in the case of these pieces here, we need to remove the folds and wrinkles before we can optimize. And the way we do that is just with a different pre-flattener. So this piece here, we can try our smart fracture. This piece is fairly close to developable surface. So a smart fracture gave us a pretty nice looking result here. We can see from the colors of it that we have fairly low strain all throughout the pattern piece. We're seeing mostly white. We do see a bit of color in these areas here, but overall this is a very good looking pattern. So we can stick to this pattern here. We'll do the same thing for the outside left. Again, we have folds and wrinkles here identified by the green check marks. So we are going to try a different pre-flattener. We will try smart fracture. And again, we've removed the folds and wrinkles. We've lowered the strain on the pattern piece. So this is a good starting point. As we look at our whole model as a whole, we don't have a lot of pattern pieces. Our seat is still a circle. So we'll focus on the seat and we will do smart fracture to that. And now we have a much nicer looking pattern there. So in terms of optimization, this would be a good starting point for optimization. We've used the pre-flatteners to generate a 2D pattern, and we've used them to remove the folds and wrinkles from the pattern piece. Additionally, as we use the pre-flatteners, we also reduced the amount of strain in the pattern pieces, which is ideal for optimization. So our three main goals for the pre-flatteners are, first and foremost, we want them to generate a 2D pattern for us. Second, we want to use them to remove folds and wrinkles from the pattern pieces. And third, we want to use them to reduce the strain as much as possible before optimizing the pattern piece. The performance of the optimizer, our second stage flattener, is dependent on a couple different things. First of all, it's dependent on the number of triangles or vertices that are being optimized in the mesh. And second, it's dependent on the amount of strain in the mesh that has to be resolved. So this ties back into our pre-flatteners. As we pre-flattened our side pieces here, the color went from red to pretty much white. So if we had optimized them as pure red, that's 20% or more strain, it would have taken longer to optimize than what we have now with them being pure white. So the more strain you can remove with a pre-flattener, the better. So in a typical workflow, you would open up your flattener window here. We would do one of our uniform remeshers. We're going to look at that next, and that would reduce the triangle and the vertex count of your mesh. And then you would use a pre-flattener to both remove any folds or wrinkles that may be in your mesh, but also to reduce the strain, because the pre-flatteners are so fast, we can use them to reduce the strain, and then we can ultimately optimize the pattern piece. So moving on from our pre-flatteners, our next grouping of tools over here, actually this icon right here is our material editor. So if during the conversion process you accidentally click the cancel button or you forgot to assign a material to a pattern piece, you can do that in two different ways, and we'll look at another way after we're finished with the flattener window here. But if you forgot to assign a material to your pattern piece, you can click this button here. This will open up the material selection interface and allow you to assign a material to your pattern piece. As I mentioned previously, the materials do contain the mechanical properties of your fabric. So you do need to assign a material to your pattern piece in order to be able to optimize your pattern piece. You will not be able to optimize your pattern pieces. That is the second stage flattener. You will not be able to do that until you assign a material to your pattern piece. So our next grouping of icons here are our remeshers. We have our uniform remesher and our adaptive remesher. These two tools have the exact same goal. They are used to analyze the curvature and the 3D shape of a mesh and produce a new mesh over top of the original with a lower polygon or vertex count. The two remeshers function slightly different from one another. With the uniform remesher, we typically set a target vertex count and we set some fidelity constraints, and these are changed. We change these in the ExactFlat options, and we'll look at how we change these options tomorrow when we look at the ExactFlat options. So with this one, we set a target vertex count, and the uniform remesher will remesh to that target count. The adaptive remesher differs in that we simply specify the maximum allowed distances from the old mesh to the new mesh. So we can set the maximum allowed distance in terms of surface to surface. We can set that in terms of boundary to boundary. And we also set the minimum allowed edge length of any triangle edge. And using that information, the adaptive remesher will automatically determine how many triangles to place onto that mesh to both minimize the triangle and the vertex count while maintaining the curvature of the mesh. So in a normal workflow, I would recommend using the adaptive remesher. Typically, when we use the adaptive remesher, it produces a really nice looking mesh. But for this particular seat here, because we have a lot of double curvature on it, specifically around the arms, and due to the complexity of the triangulation, we actually get a better result using the uniform remesher. So for this particular chair, we're going to use the uniform remesher, even though in a normal workflow, we recommend the adaptive remesher. Our next icon is the optimize icon. So when we click this, we will launch the optimization process, and we're going to look at not only the remeshers, but the optimize icon in a moment here once we finish up with our toolbar. But when we click this, we will start the optimization process, and that will relax all the strain on the pattern pieces to as close to zero as possible. We're going to be minimizing the average energy density across the pattern to as close to zero as possible. Our next icon here, if we are running one of the remeshers or the optimizer, this icon will appear, and this will basically halt the optimizer or the adaptive remesher. So if you start in a process and realize that you're not ready for that, so if I accidentally click the optimize button and I realize I'm not ready, I forgot to optimize, I can cancel the optimization and it's not going to do any optimization to the pattern pieces. Our last icon here is the broom icon. And if we do some kind of operation, let's say for this chair here, I know the adaptive remesher isn't the best remesher, so let's say I accidentally click that and I want to undo the effects of the adaptive remesher. I can click the broom icon here, and this will essentially restore the original input mesh that was generated by SolidWorks. So after clicking this, I'm going to see my original mesh being restored. There's a lot of different buttons here. However, in a typical workflow, you don't need to press all of them. So the only time we really need to play with the pre-flattener buttons is if we notice any kind of fold or wrinkle on our pattern, or if we have an extreme amount of strain on it. So if we saw after remeshing or after flattening one of our pieces was red like this, that would be a good use case for using a pre-flattener on that piece. But in a typical workflow, all we do is when we open up the flattener window, we would remesh our model, and then after remeshing, we would optimize the model. So even though we have all these controls here, in a typical workflow, we only press 2 buttons. So after opening the flattener window, Normally what we do is we just remesh. In this case, I'm going to use the uniform remesher. And as this is running, we can see it's reducing the triangle and the vertex count. And once that's finished, we would then optimize our pattern pieces. So we'll start the optimization process, and very quickly we are going to see ExactFlat take over, and it's slightly changing the shape of our pattern pieces. As the shape is changing, we're going to turn our edge highlight off to make this easier to see. We can also see the strain on the pattern is being relaxed, it's being minimized, and we can tell that it's being relaxed and minimized just by the color of the pattern pieces. So for most pieces, we have mostly white, indicating no strain. We have tiny bits of cyan on our pieces, which tells us that we have up to 5% strain. And in some pieces, we actually have a bit of gray here. So gray represents sag on the pattern pieces. If we see sag, that tells us that we have a bit of excess material, and that may manifest itself on the final sewn product as puckering or fingers of material, just because there's an excess of material in that area. So we can use this to help us make decisions on how to refine our pattern. If this is okay for your pattern, then you don't have to make any change. But if you don't want any sag, let's say we don't want any sag specifically right here, this may be an indication that we might have to split this part into multiple pieces, or we might have to add a dart or a relief cut. And we can do that simply by undoing the flattening process, and we can split our part either in half, or we can split out a small dart of material and then redo the flattening process without that dart of material. So at this point, we have remeshed our part and we have optimized it. So assuming we don't have any folds or wrinkles and our part has been sufficiently optimized, we can then click the OK button, and this is going to update our planar surfaces in the SolidWorks environment with the results of our flattening process. So after flattening, we have our optimized 2D pattern pieces here in the pattern viewport. From here, we can start our patterning process. It's difficult to really tell where these different pattern pieces go and how they sew together. So the first thing we normally recommend is using the Move Pieces tool to arrange our pattern pieces. The tool has a variety of different modes. The first mode is the translation tool, and this tool allows you to simply drag and drop your pattern pieces. So I'm dragging this piece around. We can see the gray highlight of where my pattern piece is going to go, and when I release my mouse button, the piece is moved up there. Internally, this just uses move copy bodies, so you can manually insert your own move copy bodies. However, the Move Pieces tool is a much easier way to just drag and drop your pattern pieces. We also have a rotation tool. So with this tool, when it's active, when I click my mouse button and drag, I'm rotating my pattern piece. And again, we can see that gray preview of where the pattern piece is going to go. So we can rotate this to however much we want, and it will rotate our pattern piece for us. We have two alignment tools. We have our vertical and horizontal alignment tools. And for each one, for horizontal alignment, we can pick either a bottom edge or a top edge. And for vertical alignment, we can pick either a left edge or a right edge. And we can use these to help us align our pattern pieces so they are in the correct orientation. If we look at these two pieces down here, we've got very long straight edges. We know that these are on the backrest, and we know that these edges should be perfectly up and down. So we can use our vertical alignment tool to help us arrange these pattern pieces. For this piece down here, I know this is supposed to be on the left-hand side, so I've got my vertical alignment tool selected. I have left edge selected, and when I click and hold on this piece, we can see it's rotating. So this part, that selection point, is perfectly up and down. I'm just going to move this piece up here. And our last tool is our Find tool. This tool is used to find neighboring pattern pieces. We can set an optional offset here. I like to give myself a lot of extra material, so I'm going to change this to 300 millimeters to give myself a lot of space. When I click on an edge, again, I'm going to click and hold. We have our preview on the left-hand side, and we also have a green dot appearing on that edge. So for this particular edge, because my edge is pretty much straight, we're not going to notice a big difference. But as I move my cursor up and down, we can see our gray preview rotating. So the pattern piece is tangent at this green point. We'll notice a bigger difference over here as we start finding this neighboring piece here. So as I move my mouse, it's rotating my pattern piece. So my two pieces are tangent at that same point at a distance of whatever my offset was set. So once we have a desired location set, just release your mouse button and ExactFlat will snap the pattern piece to that location. Find our top piece up there. And then this piece kind of sits down here, but it might be better just to move that up here. So what I'm going to do is I'm going to use my bottom edge alignment tool, rotate that to a bottom edge. I'm just going to translate this piece up here like that. So now that our pieces have been arranged, it becomes pretty clear how this sews together. So we can start adding our seams and hems. If after using the Move Piece tool or any other tool, you notice that your seam and hem tools are not available, just click in the empty white space here and that will reactivate the toolbar for you. Now that we can have access to our seam and hems tool, we will open up the seam tool and we can start to add seams to our pattern piece. It's very important that you think of seams as individual sewing operations. That is, you have to create your seams the way they would actually be sewn together in the assembly process. A lot of the times, people will tend to just rectangle select everything, and if you do that, you will probably succeed in adding your seam allowance to your pattern pieces. However, none of your notches are going to align, and that's simply because you're considering every single edge in your document here as one side of a sewing operation. So you need to consider this as a sewing operation, and when we start selecting our edges, you want to select them in the order that they would be sewn together. So if we zoom in on this part here, we have one really big long edge in the center, but we have a very small tiny edge down here at the bottom and a tiny edge at the top. So we want to make sure we select them in order. So we'll start here at the bottom, we'll select that edge, and as I select that edge, we have a green dot showing the start of that edge, and we have a red dot showing the end of that edge. We can also see the additional material that has been automatically added to our part as part of our seam allowance. If we zoom out, we can see over here on the neighboring pattern piece, we also have the exact same information being shown. So we have our green dot here at the bottom and our red dot at the top. As we start selecting additional edges, we can see that our seam is being expanded, and we'll make sure we pick our final edge. So we can see that ExactFlat automatically recognizes and finds the neighboring edges for us. It's really important that we want to make sure that the seam starts and stops on the exact same side. So we want to make sure that in the case of this particular edge here, both our green dots are at the bottom, and on both sides we're sewing up the pattern piece and stopping at the red dots up here. If for whatever reason one side was reversed and not in the correct orientation, over here in the seam PMP, we can simply click the reverse direction button here to reverse the direction of one of our sides. Scrolling down, we can do additional things to our seams. If, for documentation purposes in SolidWorks drawings, we wanted to add a seam table with more specific information, we can give our edge a name. For the purposes of this demo, though, I'm just going to leave this empty. But if we were to give our edge a name and we did add an edge table, the edge name would appear in that edge table for descriptive purposes. Below that, we have our seam properties. This is where we can adjust the amount of additional material that is being added to our seam. So for this particular file, my default is 1/2 inch pinch. If I wanted to change this to something else, I can do that by just changing my seam type here. If I select 6mm join, we can see material has been removed from our seam allowance on both right and left hand side. And as I pick additional seams here, we can see the amount of material is being changed depending on my type of seam. We will look at the end conditions of the seam as we start adding additional seams. It will become a little more clear what the different end conditions do. So we're going to skip the end conditions for this seam here, and we will look at this with our next seam that we create. Scrolling down, we now have our notch chain properties. So if we wanted to apply a chain of notches to this edge, we can do that by simply turning on the notch chain. When we turn it on, we're immediately asked to select a notch type. I will pick our 1/4 inch V notch. And very quickly, we will see an array of notches appear on our edge. We can control the number of notches that appear by simply changing the number of notches on our edge. So if I change this to 9, we now have 9 notches arrayed along that edge. If we want to, instead of specifying the number of notches, if we want to specify the distance between notches, we can do that by changing our mode from count to spacing. And now we can place notches at whatever interval we want. So right now it's 100 millimeters. If I change this to 200 millimeters, then the distance increases. So we can change the way we create our notches either by specifying a notch count or by specifying the distance between notches. So once you've finished adding your notch and setting your end conditions, your notch chain, we can then go ahead and click OK, and this will finish adding the seam for that particular notch. In most cases, after you've finished modifying or creating a new seam, your edges will still be selected, and the implications here are if we go to open up the seam PMP again, if you already have an edge selected when you open up the seam PMP, your seam PMP will be opened up in edit mode. So you will be editing the seam that you just created. If you notice that you already have a seam there, just go ahead and click the red X. That will close the PMP. And then click in the white space to deselect your edge. This will deselect the edge and allow you to create a new seam. Another option is to pre-select your edges first, and this guarantees that you won't be opening up your seam PMP in create mode. So if you pre-select your edges first, this will eliminate the chances of opening up the PMP in edit mode. So we're going to add the next length of seam down this side here. So we select our top edges up here, open up the seam PMP, and ExactFlat will automatically detect our neighboring edges for us. ExactFlat remembers the last settings used, so because we already configured our previous seam to be a 10 millimeter join with a notch chain with 9 counts, ExactFlat automatically applies those settings to every single seam created afterwards. So the previous seam settings will always be applied to the next seam. We're going to have a look at end conditions and how they work. And these are applied to the ends of a seam. So on this particular seam here, we can see we have our green dot there, and we have 2 seams coming together. So the default end condition for most of our seams is trim extend, and what that does is instead of having our seam simply extending from the edge, it's going to extend our seam line and trim it at the intersection point of where the 2 seams meet. We can change the default end conditions by turning off use default end conditions, and this gives us access to all of our different end condition types. Trim extend is the default. Our other types are chamfer angle and chamfer to corner angle. So if I change this edge to chamfer angle, we can see that we are no longer trimming or extending the edge and trimming it. So the angle is always going to be a deflection angle from the perpendicular direction of the edge at that point. So 0 is no deflection, so we have basically a mitered edge here. If I change this to, for instance, 45 degrees, we're going to notice that edge is now being rotated 45 degrees inwards. So you can change your chamfer angle to whatever you want. This is very useful for hiding excess information or excess material, so you don't have a large amount of material balling or bunching up at your corner of your seam. Chamfer to corner angle is very similar. This option simply attempts to mimic the intersection angle over here. So you have a very smooth flat seam. So it doesn't show very well on a 90-degree corner, but with other seam types, you'll notice that it's going to be trimmed to the same angle as the intersection, just so when you fold that down, you're not having excess material sticking out. So for this particular seam, I'm going to leave it at our default of trim extend, and we will move on. So we can carry on adding seams to the remainder of the part. And in most cases, because ExactFlat automatically applies the last settings used, all you have to do is select your edges, open up the seam PMP, and then you can click the OK button, and ExactFlat will create your seam for you. For our last few seams down here, this is where parts of our cushion sew together. So we will create our seam along the front here. And in this case, we can see our seam is actually jumping from one piece to the next. So that's telling us that even though we have one continuous piece of material here, this sews to a composite of two different pieces. So this isn't necessarily a bad thing, and this is quite common. So the jumper just tells you that our seam is starting over here, and then it jumps over to this piece here. For the bottom of our chair, we may want to add a hem or additional material to include a drawstring. So if we wanted to do that, we can use the hem tool. The hem tool is almost functionally identical to the seam tool, and they both kind of do the same thing. The only difference is the hem tool is a single-sided operation. So with a seam, we are adding additional material to two sides of the pattern piece, the right and the left-hand side. With hem, we are only adding additional material to one side. So we will start by selecting our edge. Now we can open up the hem tool. And unlike the seam tool, we only have our primary selection here. Most of the tool is exactly the same. We still have our hem properties. This is where we can choose additional material. So whatever hem type you need, you can select that from the list. For my case, I'm going to pick 2-inch hem because I want to create a nice pocket for a drawstring. And now we have our additional 2 inches of material added. If we scroll down, we have access to the notch chain for this particular part. I don't really need notch chain on my hem, so I'm going to turn that off. And now I can apply the exact same hem to this piece over here. For this piece here, this simply sews to another part of quilting that was not included in the model. So this should actually be a seam. However, we don't have the adjacent pattern piece in the model, so I'm just going to treat this as a hem. I'm going to change this to 8 millimeters. So once we have applied all of our patterning information to our chair, I'm actually going to turn the notch chain off for this particular scene here. And we'll leave that alone. So once we've added our seams to our part, we can then move on. We can start adding things like hardware and markings. And there's two different ways that we can do hardware and markings. We can either add hardware and markings in 2D, in our 2D pattern view, or we can add hardware and markings on our 3D model. And this is really a design decision with where it's easiest to add your hardware and marking information. If it's easier to place this on the 3D model, then you can do that, and we can map the hardware and markings from 3D to 2D. If it's easier to simply place them on the 2D pattern, then you can do that as well. If you want to just place your hardware and markings on the 2D pattern, we can do that simply by clicking on the pattern piece and creating an in-context sketch. For this piece, we're going to assume that we want to add some decorative buttons, both for decorative looks and to help pull the material in. So buttons are typically point entities. They are an item that is counted in terms of quantity. And for any type of item that is counted as a quantity item, we typically use a point to represent that. Similarly, conversely, if we were to use something like a piece of ribbon or piping or a strip of Velcro, any item that is normally measured in terms of length, we would typically use like a spline or a line to represent that. So because we're going to be adding buttons here, these are items that you would count the quantity, we're going to use a point. And we are simply going to place a point everywhere where we want a button here. So I'm just going to freehand draw these here. We'll add a few and maybe two more down here. And we can dimension these however we want using the existing SolidWorks dimensioning tools. But for the purposes of this demo, I'm just going to freehand draw them. And now that my sketch is done, I'm going to close the sketch. So now we have our sketch here. We have our 8 buttons, and it's in context of the pattern piece. We still need to map this sketch to the pattern piece and effectively register this sketch so it will be included as part of the DXF when we export our DXF pattern. To do this, we just want to make sure the sketch is selected. So we've selected a sketch down there. And now we can open up either our hardware or marking tool. Because we're going to be adding these as buttons, a button is a piece of hardware. It has a physical piece of hardware item that has a cost associated with it. So we're going to use the hardware feature here. Markings effectively does the exact same thing. The only difference is it's typically used for things that don't have a physical piece of hardware. So you would use a marking for something like an annotation text or a fold line or any kind of marking that may help or aid with the assembly of your part. So they both do the exact same thing. They both allow you to transfer sketch information from SolidWorks to your 2D DXF when you export it. So we've opened up the hardware interface here, our sketch, because we selected it before we opened the hardware interface. Our selection has already been pre-populated. If you forgot to select your sketch, then all you will see is your selection. Just simply select your sketch first, and then you'll have access to the rest of the PMP. If your sketch was created in context, then your pattern piece mapping will automatically be selected. If this box is empty, just select the pattern piece that you are wishing to apply your hardware to. Similarly, with edge properties, we have the option to give our sketch a name. So if we wanted to take advantage of ExactFlat's hardware table, we can give our sketch a name, and then that name would appear in the hardware table. So for this sketch, I might just call this decorative buttons. This doesn't have any kind of effect on the functionality of how the marking or hardware is applied. This is only used for information purposes downstream when we create our drawings. As we scroll down, we have our hardware properties. This is where we can change the type of hardware. So if we select hardware, we can pick any of ExactFlat's demo hardware. We're just going to keep our button here, so we will click OK. Just like within the Edge PMP, we can change the default color. So we skipped past this in seams and hems, but each seam and hem, each piece of hardware and marking will have a color associated with it. And this is simply to help you identify what piece of hardware or marking it is in the pattern environment. So each hardware, each marking, each seam and hem will have a default color assigned to it. However, we can change the default by unchecking Use Default Color and then picking a new color. So if I wanted this to appear in my document as magenta, I can select magenta. And now when I click the OK button here, our sketch is going to turn to a solid color, in this case magenta, and that identifies to us that this sketch has now been successfully mapped to the pattern piece as a hardware sketch. Down here, we have our hem with 2 inches of material to act as a pocket. So down here, we might want to add some information to help us identify where this sews to. So we can do that using a marking sketch. We can do this in either 2D or 3D, whichever is easiest. I've already shown you how to create hardware and markings in 2D. So for this one, I'm going to switch over to my view model. We're going to go back to our 3D model, and I will show you how we can create a hardware marking or hardware sketch in 3D. So because we are in 3D, we want to make sure that we create a 3D sketch. So from our sketch tab over here, instead of just creating a new sketch, we are going to click the down arrow, and we are going to create a new 3D sketch. From here, we can place any kind of point or curve that we want onto our model. The easiest way to create a curve directly on a surface is to use a spline. Click the down arrow and select Spline on Surface, and this will create a new spline on this surface. For this particular piece, we're going to assume that this is a drawstring, so we might want to draw the sewing line for this particular drawstring. So I'm just going to freehand draw a curve on here along the bottom, and we'll assume that this is a the sewing line for a drawstring pocket. So once that spline has been created, we can now close the sketch, and we can see that that curve is very clearly on the surface of the model. You can create this sketch with whatever method is easiest for you. It might be easier to create a plane and intersect it with the surfaces. You might want to simply offset your edges. The method that you use to create your sketch is not important. The only important thing is that we either have some kind of sketch entity or point entities in the sketch, which can then be used to transfer either to the DXF directly or to the pattern piece, and then ultimately to the DXF. So now that we have our sketch created, we're going to make sure our sketch is selected. We can then switch back to the ExactFlat Tools Command Manager. And make sure our sketch is selected and not the entity down here. And now we can apply this as either a hardware or a marking. Last time we did a piece of hardware, this time we're going to do a marking. And they're pretty much exactly the same. We have our sketch selection. The model piece mapping is in most cases automatically determined in 2D view. However, in 3D view, you always need to pick your model piece mapping. So this is just the pattern piece that we want to map the sketch onto. So we will pick our inside left piece here. And then just like with hardware, we can give this a name if we want. And if we scroll down, we have our marking properties. So we're going to select marking, and we're just going to pick our fold line here. We'll keep it at fold line, but we can pick whichever marking type we want. In most cases, the marking type that you select is, again, just for documentation purposes in the drawing. Your choice here is not going to affect your DXF or the function of the tool. in all cases, we are still mapping this sketch to the 2D pattern piece, which will then be exported to the DXF. So this is just for information purposes only. So pick whichever one best describes what you are doing. And when we look at the database manager tomorrow, I will show you how you can create your own custom marking types. And not only that, I'll show you how to create your own custom hardware types, your own custom hem and seam types. So we will pick fold lines, and we will click OK, and we will click OK to close the PMP, and very quickly this sketch has now been mapped to our 2D pattern piece. So if we go to View Patterns here, we can now see our sketch down here has been mapped to our pattern piece. Now that our hardware and markings have been created, the last thing we can do is add a grain line to our pattern pieces. So it's very important that we make sure our pattern is finished and complete before we add the grain line information. It is very strongly recommended that you do not move your pattern pieces or add any new hardware or markings or use a flattener or make any kind of change to your document once the grain line feature has been added. If you've added your grain line feature and you realize that you do need to make a change, before you make your change, you need to remove all grain lines from the document. Otherwise, you will experience unexpected results and SolidWorks will probably crash. It's also recommended at this point to save your document too. So just go to File, Save As, and save your part as a unique file name. So I'm just going to use the default name here and just give it a new name here. So save often, and that will save you the need to redo all of your flattening operations. So now that we're ready to add our grain lines, we can go ahead and open up the grain line PMP. And this tool allows us to apply a grain line to our pattern pieces for use in nesting. So depending on the needs of your pattern, you may have a stripe or a plaid on your pattern piece. You may not have any kind of printed information on your pattern piece, or the material may have a very defined weave that your pattern piece needs to be aligned to. So we can use the grain line to represent how your the orientation of your pattern piece on the marker itself. So to use this tool, we first select the pattern piece that we want to apply a grain line to, and then we have to choose, we can pick either vertices on the part, or we can use an actual sketch to represent the grain line information. So for this part here, we're going to say that we want our part aligned to this edge right here. So over here in selections, I can now pick vertices. So I'll pick that vertex right there, and I'll pick that vertex right there, and that's going to create a grain line between those two vertices. So if I close the tool, we can now see our grain line preview has appeared, and that's telling me that I have a grain line on this pattern piece running in that direction. Down here, I may want the grain running vertical, so I can do that again using vertices. I will open up the grain line tool, piece selection, I will select this piece, and now for my selections, I will pick that vertex and that vertex right there. And when I close the piece, I now have my grain line running vertical. If I want to assign the same grain line to multiple pattern pieces, I can do that. And the easiest way to do that is simply to create a sketch and use a line segment to represent your grain line. So to do that, just create a sketch. I'm going to use my front plane here. I'm going to create a new sketch on my front plane, and let's say that I want my grain line to run at an angle on these pieces here. I can create a single line segment at whatever angle I want, and I can use this line segment to act as my grain line. So now I will open up my grain line tool. For my piece selections, I will select the remainder of the pattern pieces here. And now for my selection, we don't want to select the sketch itself, we want to select the line segment on the sketch. So right click on the sketch, go to Select Other, and then make sure you're picking line segment on your sketch. Once that's done, ExactFlat will project that sketch onto the pattern pieces and assign that as the grain line for all our pattern pieces. Once that's been done, we can then proceed to our marking interface. So we will open up the marker view, and now we can see our pattern pieces on the marker view. By default, the layout of the pattern pieces is going to be exactly what you see in the document view. So we have our pieces arranged there in the same fashion as what's in the document view. There's the marker interface is broken up into three main sections. At the top, we have our list of markers, and this is where we can make changes to our markers, including the material and the Layrules. Bottom left, we have our piece selections. So these are all the pieces that are on the marker. And from here, we can add or remove pieces to or from the marker, and we can also change the constraints placed on the pattern pieces on a per pattern piece basis. So we can either double click on the pieces to open up the editor or just click the edit button. On the right, we have the manual nesting interface. So this is where we see a preview of our material. So over here, we can drag and drop our pattern pieces. We can right click on them to rotate them to any orientation that we want within the constraints of the lay rule selected for the pieces. And we'll notice that as we drag our pieces, if we drag them off the bounds, they turn orange and it doesn't allow the rotation. Also, if we drag them over top of other pattern pieces, they turn red and they collide, and you're not allowed to do that. If your nest is very crowded and you just need to drop a piece at any time, regardless of whether it's colliding or off the pattern boundary, you can just press escape to drop the piece, and that will allow you to make clear room to allow you to nest your pieces manually. We do also support automatic nesting using the Fraunhofer nesting algorithm as part of our ExactFlat professional package. So we will talk about that in a little bit, but before we look at that, I want to talk about our marker list and the marker manager. So up here, we're going to select our marker from the marker list, and we're going to click the edit button to open up the marker manager. With the marker manager open, we have the ability to add new markers, or we can remove existing markers. And for each marker, we have different properties. We have our basic properties, including name and details. We have our lay rules, which include the lay rule applied to this particular material or marker. So lay rules are just named collections of pattern piece constraints. So they just adjust the default constraints applied to the pattern pieces for this entire marker. From here, we also have access to the piece gap. This is the minimum allowed distance between any two pattern pieces. So typically in a cutting system type, your cutting table operator is going to specify an overcut just to make sure that the pattern pieces are really good and cut out of the material. For tools like a blade cutter, like a wheel cutter, you typically need overcut just because of the way the cutting implement works. Wheel cutters go around corners nicely, but they need additional overcut to make sure that they fully cut all the way through the material, whereas a drag blade is very good for precise cuts, but they don't turn corners well. Lastly, we have the edge buffer. So depending on your material, it may have an unusable portion of material along the boundaries. So you may find that your material is always fraying on the edges, and as such, you can't actually use it for manufacturing or production. So you can specify an edge buffer to make sure that your pattern pieces are never going to be nested within that unusable portion of material. Our next tab is our placement groups. So this is more applicable for automatic nesting, specifically with our production manager software. So in a production manager environment, that particular tool allows you to import multiple nests from multiple parts into a single marker, and then with placement groups, you can choose how the pattern pieces from your different parts are nested together, whether you want to keep them grouped together by part or whether you want to allow them to mix all together in the same document. Our last tab is our material tab, and this is where we can change the dimensions of the material. This applies more to automatic nesting with ExactFlat Professional. And with automatic nesting, there's two different ways that Fraunhofer can represent the material. The first way is that Fraunhofer will represent the material as an unlimited roll of material, and this is useful for conveyor or continuous cut systems where you can generate one single long nest, and the cutting table will automatically pull additional material onto the cutting table surface as you are cutting your material. The other option is to use a bound surface, and this is useful for things like static cutting tables where you have to manually pull the material onto the cutting table surface, or if your material comes in a very defined stock size, such as a 4x8 sheet of material or a 2x2 sheet of material. In that case, you would use a bound surface where it has a very defined width and length, and Fraunhofer will nest onto one or more of those bound surfaces. From here, you can change your material dimensions. So if we are using bound surfaces, we can adjust the dimensions of the bound surface. So for this particular one, we have a very, very long bound surface. So you can independently change the length of your surface, the height of the surface, and the number of surfaces in stock. If you have an unlimited number of surfaces in stock, then just click Unlimited here. Or if this is a static cutting table, click Unlimited, and it will just create as many nests that are required to fit all of your pattern pieces onto the marker. If you have multiple surfaces in stock, then you can add multiple surfaces. So if I wanted to add, if you had a couple 2x2 sheets of material, you can add those, and then you can have the rest of your nests going on to the 4x4. You can add those materials there, and you can also adjust the priority and the use of the material, the ordering that they're going to be used. So there's a lot of options that you can set to define how your nest is going to be accomplished and in which order your bound surfaces are going to be used. If we are using unbound surfaces, then you can uncheck this, or if your material by default has been created as an unbound surface, then this would automatically be unchecked. And then we can modify the length of material. For unbound surfaces, it's not possible to adjust the width of the material. So for this particular material, we are always going to be at 1.5 meters. However, we can adjust the maximum length, and this would depend on the roll length of your material. So even though it's an unlimited length marker, you might only have a little bit of material left on your roll, so you can adjust the maximum marker length to accommodate the length of the roll of your material. We'll go ahead, we'll click OK. We're going to leave this marker as an unbound surface. And so once your marker properties have been set, we can then move on to our pattern piece properties. So we're going to go ahead and click the Edit button here, and this will bring up the pattern piece properties. We can adjust these properties on a per pattern piece basis, or if we want, we can select every single piece in the list and adjust these properties for every single piece simultaneously. For each piece, we can adjust the rotation increment and the rotation tolerance. The increment is the increment at which rotations occur. So for the default lay rule applied here, we picked anyway, which means that our pieces can rotate in any increment. However, if we have a very specific material like a stripe or a plaid, then we may only want to allow our pieces to rotate in 90-degree increments for a plaid to make sure our piece is always aligned to the plaid print, or we may only want to allow them to rotate in 180-degree increments. That way the pieces are always aligned to the stripe of the material. So we can do that by adjusting the rotation increment here. Set this to whatever you want. In my case, I'll change it to 90 degrees. And then if you want to allow a plus or minus variance from that 90-degree increment, then you can set a tolerance. So if I set a 2-degree tolerance, then it's going to allow me to rotate my pieces at 90 degrees plus or minus 2 degrees. So that gives me a 4-degree window of rotation. We can also adjust whether we want to mirror our pattern pieces or match the rotation of our pattern pieces by turning those on or off. If we turn mirroring on, and not only am I going to get a copy of my pattern pieces as seen in the marker view here, but I'm going to get a mirror copy of my pattern pieces. So if you design your part as only one half of a part, you can turn on the mirror option, and that will effectively mirror your pattern and give you both halves during the nesting process. The match rotation will enforce a constraint where every single copy of a pattern piece will have the exact same rotation. So if you want a very uniform run of product, you can turn that on to make sure that every single copy of your marker will have the exact same orientation of pattern piece with respect to the grain of the material. Parent multiple and mirror multiple adjust the multiplier for your piece count. So for parent multiple, if I wanted to add additional pattern pieces, right now I only have one copy of each pattern piece. Let's say I wanted to do a production run of 10, I can change my parent multiple to 10, and that will effectively add 10 copies of each pattern piece to my marker. Similarly, if I have mirror piece turned on, I will then be able to adjust the mirror multiple, and that will adjust the number of copies of mirrored pattern pieces that are on my marker. Allow flip and allow in X and Y enforce constraints of whether your pattern piece is allowed to flip itself in the X or Y orientation. So this is very similar to the mirror function. So if your material doesn't have a finished side and an unfinished side, if it's the same on both sides, such as a roll of cotton for something like a t-shirt, then you may want to allow your pattern piece to flip in the X or Y orientation, depending on which gives a more efficient nest. So you can turn those on or off if your material allows you to do that, and if you don't mind your pattern pieces to flip, depending on whether your material is printed or not, you might get a better nest with that. The last two options here are X and Y pattern offset. These aren't really used internally, so we don't recommend changing these. So just leave these at 0 for now, and once you set the rest of your pattern piece constraints, you can click OK. So after changing our grain orientation, our allowed rotation here, if we try to rotate our pattern piece, we're going to see that it is snapping to our grain line is snapping to our rotation increments here. And because we set a plus or minus 2-degree rotation increment, we can see there's a tiny bit of play in there with how it's being rotated. Also, because we adjusted our parent multiple, we can see over here it's telling us what our multiple count is, and over here in the right hand column remaining, we can see that we have 9 copies of our pattern piece remaining in inventory, ready to be added to the marker. As I mentioned previously, the default arrangement for the pieces on our marker is exactly as what we see in our pattern viewport. So if we are not using automatic nesting, then there are a couple options to adjust how our pattern pieces are automatically placed into the viewport. If you don't want them all stacked on one another, we can adjust the initial placement options, and we can do that for this marker only by clicking the cog icon down here, and this will open up the placement options. The default option of none will basically place your marker pieces exactly as you see them in the pattern viewport. We have a number of different options here. Box packing will attempt to perform a basic nest of the pattern pieces. So I'll select box packing. I'm going to close the placement options, and I'm going to click the repack marker button here. And when I do that, we can see our pattern pieces are automatically being rotated, and a basic nesting is being done to the pattern pieces to try and place them onto the marker. This piece up here failed to place because ExactFlat was not able to rotate this in any orientation that allowed it to fit onto the marker such that it did not go off the edge. For the initial placement here, it's only going to perform a rotation if the rotation is allowed within the constraints of the lay rule. So for that reason here, I can manually rotate my piece and I can drag it on and it will fit. But the automatic rotation is being done to try and produce a pattern piece that has a minimum height configuration. So that's why the placement for that piece failed. We'll look a bit more at that option as we explore the placement options here, but for now I just wanted to show the effects of the box packing. We have a couple other placement methods, including linear left to right. This will just array our pattern pieces across the bottom of the marker, or the middle, or the top, and that really depends on the linear placement alignment, whether that's set to bottom, top, or middle. We also have linear right to left, salvage left to right, and salvage right to left. These last four options aren't very useful in a normal nesting environment. However, these are here more to support the pool and spa industry. So in most cases, you would use either none or you would use box packing. Once our pieces have been placed on the marker, you can continue using your manual nesting tools, or we can proceed to automatic nesting. But we still have our pieces remaining in inventory over here. We still only have one copy of each pattern piece on the marker. To add the remaining pattern pieces to the marker, we simply select the pieces that we want to add, and we click the four arrow icons down here. And this will add all remaining pattern pieces to the marker for us. Again, because automatic rotation, we weren't able to place these pieces up here, but we can either do that through manual nesting, or we can just let Fraunhofer take over and add them to the marker for us. So I'm going to bring up the placement options one last time, and I want to talk about auto rotate on bulk placement. This option will attempt to rotate your pattern pieces automatically so they consume the least amount of height as possible. This helps to ensure that our pattern pieces will always be able to be placed onto the marker. The reason these pieces up here are failing to be placed on the marker is simply because the minimum rotation is a rotation increment that is not allowed by Fraunhofer due to the constraints of the pattern piece that we placed on it. We only allowed it to rotate 90-degree increments. So that's why the automatic placement is failing. Before we nest our pattern pieces here, we're going to actually go to our marker properties, and we're going to change the material properties here. We only have a 12-meter length of material here, so we might want to change this to something a little bit longer, just so we can fit all of our pieces onto the marker. So I'm just going to change this to 127 meters, and when we click OK, we can see that we have a much larger roll of material, which allowed most of our pieces to be placed on there. The only ones that aren't placed are these pieces up here, simply because the automatic rotation to a minimum height is violating the lay rule constraints. However, if we manually rotate these, we can actually place them on the marker, and Fraunhofer will be able to do that for us. So once your markers have been set up, and once your piece constraints have been set up, and you're ready to nest, we can then click the Nest button down here, and this will open up the Fraunhofer automatic nesting interface. There's only two options here. There's target yield, and there's maximum runtime. Unless you're nesting squares in a perfect square, you're probably never going to reach target yield. This is basically how much of your material, or what percentage of available material, is being used. So a typical target yield is going to be anywhere from 60 to 80%. Anything above that is really, really good and really efficient. But again, it's very unlikely that you're ever going to get to 100%. So in most cases, you typically just change the maximum runtime. So this is the amount of time in minutes that the nesting algorithm is going to run. And as it's running, it's always going to present you with the newest, best result as it comes up. So in most cases, you can get a really good, really efficient nest in a matter of a minute. But if you're working in a production environment, specifically if your material is very, very expensive, or if you're doing very large runs of parts, then you might want to set this to something larger, like a couple hours, just to make sure that you're getting the most efficient nest possible. So once your yield and max runtime have been set, just go ahead and click the Nest button, and very quickly Fraunhofer is going to take over, and it's going to start arranging our pattern pieces automatically for us to fit them onto the marker as tightly as possible. So already after a few seconds, we can see that our yield is up to about 75%, so we have a much more efficient yield than what ExactFlat's box backer was able to produce. So nesting has finished. So we're going to go ahead and click the accept button here, and this is going to accept the automatic nest, and it's going to update our manual nest over here with the results of the automatic nester. So we'll go ahead and close that, and now we can see the results of Fraunhofer. At this point, nesting is complete, so we can now proceed to export our pattern to a DXF, and we do that by clicking the export button down here. So once we click the export button, we now see the export profile manager. And this is where you can pick the profile that you're going to be exporting to. ExactFlat provides a number of different profiles for different cutting table systems, including Onometrics, Eastman, and Gerber Cutworks. So you don't have to use our profiles. Using the database manager, you can create your own custom profiles. And really the only difference between the different profiles is the layer names and the color of the layers and the entities that are being exported. So an export profile basically describes which elements of your flat pattern are going to be placed onto the DXF, and it describes what layer those different elements are going onto and what the color of those different elements is going to be. So ultimately, when you import your DXF into your cutting table system, your cutting table is going to scan the DXF, and it's going to assign different tools such as your blade, your drag blade, or your wheel blade, or a pen tool. It's going to assign those different tools to the different layers in your DXF. So you want to make sure that your layer names are correct. That way your cutting table is going to correctly recognize all of the features of your DXF and cut it out exactly the way you want. So if we look at our Eastman profile here, for instance, this profile includes all of the annotation features. We have all of our hardware and our marking features. We have all of our notches. Our sew lines are being exported to the pen me layer, and our internal perimeters and our pattern perimeter are both being exported to the cut me layer. If we compare that to something like a Gerber Cutworks profile, we're not exporting as many entities. Notably, all of our annotation entities are not included in this profile, and the layer names are different. So our sew line is going to the pen layer, our internal perimeters and our pattern perimeter are going to the cut layer. And again, if we compare this to something like Onometrics, the layer names are even further different. Onometrics is kind of unique. It relies more on color to identify the different tool. So again, you want to make sure both the layer names and the colors are correct. Once you have finished selecting your profile, you can then click the export button, and this will create a DXF for you. It will ask you to choose a location to save your DXF, and then you can save your DXF, which you can then send to your cutting table. Once you have finished with your pattern, we can then close the marker interface, and we can proceed to create a drawing for your part. So ExactFlat leverages the existing SolidWorks drawing tools in place. So to create a drawing, we just go to File. Actually, it's a good idea to always save your part before you create a drawing. So we go to File, Make Drawing from Part, and then all you do is you select your template. Your organization will probably have a custom template created here that includes your own personalized data block. So pick whichever template you need and click OK, and this will create a new drawing. We then pick our paper size and click OK. And once you've done that, you can then drag your different views onto the document. So this is exactly the same as the existing SolidWorks drawing tools. There's no difference here. You just drag your views on, and that will create the drawing for you. ExactFlat does augment the SolidWorks drawing tools with some additional information. Most notably, we can see the seam allowances have been added here, as well as the notch symbols for our notches. We can also see the grain lines on our pattern pieces as well. So you can use any of the SolidWorks drawing tools to create your standard drawings, and then ExactFlat also includes a few additional features in the ExactFlat drawing tools command manager. From here, we can add different tables, such as piece tables, material tables, edge, notch, hardware tables, and we can add balloons to the different elements of the pattern to help correlate those different elements with the tables. We also have callouts. If you want to skip the table and balloons, the callouts will add all that information as a very defined tag on your pattern piece. So if we wanted to add an edge table showing us what all of our different seam allowances and hems are, we can click on Edge Table. We can pick our table template here. I'm going to change this to Detailed, and this will generate an edge table. So we will drop our edge table right there. And now over here, we can start adding balloons to identify our different edges with the different edge IDs in the table here. So from this table, we can see all of the different seam types. We can see our 10mm joins, we can see our 2mm hems, our 8mm hem, and so on. And it will tell us what the length of those edges are. As we start adding our piece balloons, we can start identifying the different edges to the different entries in the table here. So if I pick this edge here, I can add an edge balloon, and I can change the style here. I might want to change this to some other shape, such as a circular split line. Circular, and this just allows us to identify the different edges. So this balloon tells us that this edge here is edge 6. If we look in the table, that's a 10mm joint. So we can proceed adding all of our different labels here. My apologies, this is piece balloon, so this is telling me piece ID. So I'm actually going to click the red X, and I'm going to delete all these balloons here. So if I added a piece table, this would tell me what my different pieces are. So this time we're going to pick edge balloon. So it's telling me this is edge 20, which is a 10mm join. This edge over here is edge 10. We have edge 16, 3, 6, 1, 2, and so on. So balloons simply reference the different IDs in the corresponding table and help you correlate your pattern information to the different table entities. Whereas a callout, we can use callout for the different piece names. This will simply tell you what the name of the piece is, and will tell you that directly on the drawing. So that's our outside left. This piece is our backrest. This one here is seat. Inside right, outside right, and outside left. So it looks like we mixed up our names a little bit there, but that's okay. We can fix that later on. So once you're happy with your drawings, you can then do whichever procedure is recommended by your company. You can either save your drawing to a SolidWorks drawing file, or you can save it as a PDF for import into a PLM system. So ExactFlat drawing tools, they simply augment the existing tool set of SolidWorks drawing tools. So you can use whichever tools you want, however you want, to create your best drawings. Next, we have the strain legend. So this shows us ExactFlat strain legend used by the Flattener to tell us visually how much strain we have on a part. You can add or remove any entry that you want from the list here. And negative numbers actually represent sag, and we have a visual preview of what the legend will look like down here. So with the default legend, gray is anything more than 0.5% sag or negative 0.5% strain. White indicates no strain whatsoever. Cyan is 5% strain. Green is 10%. Red is 15%. And red is 20% or more. So we can see the effects of the strain map. I'll just turn off our edge highlights and our piece normals over here. If I were to change these, there's lots of different ways we can use the strain map to our advantage. One way is to use it to indicate a very hard limit. So if we are good for anything up to a very certain amount of strain, we can use the strain map to tell us that the second we've violated that strain constraint. So over here, instead of the default legend, we might create a legend something like this where 4.9% represents also white, but 5 represents red. And then we can remove the other entries. So now everything up to 5% is going to be white, and the second we get to 5%, it's going to go to red. So we can see the effects here, and this just very quickly tells us the vast majority of this pattern is under 5% strain, and there's only a few spots here that go over 5% strain. The remainder of the buttons here don't actually have any effect on the behavior of ExactFlat, so it's recommended just to leave them alone. So we'll switch over to the Piece Creator tab. This is where we can modify the settings associated with the Piece Creator tool. So we mentioned on Tuesday that the Piece Creator simply uses the SolidWorks surface knit features to do its merging of faces. So we have the piece tolerance and the piece gap width here. These are direct correlations to the surface knit feature. So you can adjust these however you want to help you close up gaps. It is worth mentioning though, if you do have an intentional gap or slit in your part, such as a dart, you want to make sure that the knitting tolerance and gap width are smaller than the width of your slit to avoid them being unintentionally knitted together. Below that, we have the Piece Creator Naming template editor. So when we started creating our pieces, our pattern names were simply 1, 2, 3, 4, and so on. And that's because of the way the naming template is configured. There's always going to be, unless you manually set your pattern piece name, there's always going to be a hard-coded number or letter appended to the end of your piece name, and that's controlled here. You can select whether you want a number or a letter automatically appended to your piece name. Below that, we have our actual template editor, and this is where you can edit the name of your template. So the pattern piece name is always going to be in the format of whatever is in this box plus the number or letter appended to the end of it. So because this box is empty right now, I'm simply getting my number appended to the end of my pattern piece name. If I were to type something else in here, such as ExactFlat, and this is the default naming template, ExactFlat, now all of our pattern piece names are going to be in the format of ExactFlat 1, ExactFlat 2, ExactFlat 3, and so on. We can add additional modifiers to the name that help us better correlate our parts to the project that we were working on. So if you're working on a really large project, we might want to include the file name as part of our pattern piece name. This would become useful if your file names correspond to some kind of part number or project or job or batch number. It can help you track your pattern pieces a little bit better. We can also include the body name as part of the Piece Creator naming template. So if you have some kind of process in place already where you are creating surface bodies that are already named the way you want them, you can use the Piece Creator and just select the surface body explicitly instead of pulling faces off of it, and you can have surface body as part of your naming template, and then ExactFlat will just use the name of the surface body to to form its name. Lastly, we have SolidWorks properties and SolidWorks custom properties. So if your file has a property in it that you want included as part of your name, perhaps you've got custom properties that are set with work order numbers or something, then you can set it to SolidWorks custom property and adjust your sub value to select the property that you want. In the case of property, we've got keywords, we've got authors, so we can include those as part of the file name. And then for custom property, any custom property that's included as part of the file can be added to your piece creator name. So actually, I'm going to stop myself right here. I just realized I'm using the IKEA chair, not the Benson chair.
Sorry. Yes, that's I was wondering what was there. I didn't know if that was anyway. Okay, fine. So you want to just
I'm just going to carry on.
What's that?
I'm just going to carry on from where I left off.
Okay.
So for custom properties, if there are custom properties, they'll appear in the list here. If there's nothing, the box will be left empty. So let's say we wanted to include file name as part of our naming template. We select file name here, press the plus button, and that will insert the file name replacement identifier into the list. Once you're happy with your file name, you can click OK. And now when we go to Piece Creator, every single piece we create is going to be named using the file name as part of the Piece Creator name. So for custom properties, if there are custom properties, they'll appear in the list here. If there's nothing, the box will be left empty. So let's say we wanted to include file name as part of our naming template. We select file name here, press the plus button, and that will insert the file name replacement identifier into the list. Once you're happy with your file name, you can click OK. And now when we go to Piece Creator, every single piece we create is going to be named using the file name as part of the Piece Creator name. So we'll move on to conversion. Actually, I'm going to reset my name here so it's just a letter or a number. And now we'll move on to conversion. The conversion tab contains a number of automations. It's not recommended that you change any of these. The first one, assign material on convert to ExactFlat. If this is unchecked, you will not be prompted to assign a material to your pattern pieces when you convert to ExactFlat. We strongly recommend that you leave this checked. You will not be able to optimize your pattern pieces unless a material has been assigned. So there's really no reason to not assign a material to your part on conversion. Also, if you don't assign a material, then the automations that allow you ExactFlat to automatically create a marker will not be able to engage. So it's strongly recommended you leave this checked. That way you will be able to assign a material on conversion to ExactFlat. The second option down here is more of a specialty option that was designed for a specific industry. Match material body to ExactFlat material on convert to ExactFlat. If you have a SolidWorks material that has the exact same name as a material in the ExactFlat material database, then ExactFlat will automatically use the material from the ExactFlat database that matches the body material, and it will automatically assign that material to your part for you. The default demo database does not have any matching material names, so this is something that you would have to set up yourself. So if you do take the time to set up your database, both your material, ExactFlat material database and SolidWorks material database, then there are some savings that can be had there. You can turn this on, and then during conversion, whichever materials match will just automatically be assigned. The last option here, automatic remesh. This will automatically apply either the uniform or adaptive remesher to your part during the conversion process. The default is off, and that is the recommended setting. The reason being is if automatic remeshing is occurring, you don't get to see the original input mesh, so you can't evaluate it for its fidelity. So you have no idea if it's a high quality mesh or if there are any kind of meshing errors that may be translated downstream. If you know that your meshes are always going to be a good mesh, if your parts are always very similar, then you can turn this on and it will save you a little bit of time. However, it's a good idea to check your meshes right from the SolidWorks mesh all the way down, just to make sure that you have a good high quality mesh. Moving on to the Remesher tab. This is where we can adjust the parameters and the settings of the uniform and the adaptive remesher. Starting with the adaptive remesher, we have our fidelity constraints here. So this is where we set the maximum allowed distance from the original mesh to the new mesh. These are set as factors, so the true distance is automatically computed by ExactFlat, and these are just simply multipliers that allow you to adjust the relative constraint. So surface is the maximum allowed distance between the old mesh surface and the new mesh surface. Boundary is the maximum allowed distance between the old mesh boundary and the new mesh boundary. And then lastly, minimum edge length factor is the shortest length that any edge is allowed to be created as. Minimum edge length factor is more of a suggestion. The adaptive remesher can and will violate that if it's absolutely required to meet the minimum surface and edge boundary constraints. So it's more of a suggestion, but as a general rule, it's a good idea to keep this fairly close to the smaller of these two, the surface and the boundary. We do have some additional options down here. The defaults are the recommended settings. We don't recommend turning them off. Detect short curves will attempt to detect small micro variations in the mesh, and if detected, it will preserve them. So for fidelity sakes, if you have like a small break in your part or a small change in angle of your part, detect small curves won't make an attempt to try and detect that. So it's best to turn that on to preserve the fidelity of your part. Detect narrow surfaces will attempt to identify and detect small bridges or narrow strips of surface material on your part. And when found, it will do its best to preserve that. If that option's turned off, it may be perceived as more of an outlier or an error in the mesh, and the adaptive remesher may remove those triangles from your mesh. Assume disc-like closing. We'll just assume that your part is closing in the fashion of a disc. It's not really true for most parts, so we don't recommend turning that on. It's more of a specialty tool. On closed error, leave holes. If there's an error in the mesh, if due to the nature of the way the adaptive remesher does its work, sometimes you will have errors on the interior of the part. So with on error leave holes turned on, it will just simply leave a hole in your mesh, which is not ideal. So we recommend leaving that turned off. And when ExactFlat detects that there's a hole as a result of the adaptive remesher, ExactFlat will attempt to close the hole for you. The common refinement closing is an alternate method for finishing up the adaptive remesher. It is slightly more expensive computationally. However, it reduces the chances of an error occurring on close. So we recommend leaving it turned on. The performance impact is very, very minimal, and you get a much better looking mesh free of errors using that method. So it's recommended that you just leave that turned on. Moving on to the uniform remesher. The uniform remesher works slightly differently. So we have our surface and boundary fidelity constraints. You can adjust those both in terms of smoothness and distance from the original mesh. And then down here we have our desired output vertex count. So with the adaptive remesher, we adjust our tolerance factors and it will automatically determine the number of vertices. With the uniform remesher, we explicitly tell the remesher how many vertices we want in our output mesh. So you can adjust that here. Moving on to the Flattener tab. The first section deals with tessellating, creating your mesh from SolidWorks. So this is how we can adjust the relative quality of the mesh that is being generated by SolidWorks. By default, we use automatic tolerances, and this will scale the coarseness or the fidelity of your mesh by giving a percentage value, and it will scale with the size of your model. SolidWorks, when we create a mesh from SolidWorks, you tell it what you want your minimum facet width, maximum curve core tolerance to be, and it will create a mesh according to these parameters, very much the way the adaptive remesher does. But unlike the adaptive remesher, this does not scale with part sizes. So if you go from designing something like a watch, the meshing parameters you use for a part that size are no good for something the size of an automotive vehicle, a car, or a truck. If you make that jump and you use the same meshing parameters, now you're going to have millions of triangles in your mesh for the truck. So it becomes very cumbersome. You always have to come back here and manually adjust these values to get a decent sized mesh for your size of the part. Automatic tolerances aims to correct that or remove that burden by automatically scaling these values to the size of your part. So the default is 50%, and that will give a very decent quality mesh. For demonstration purposes though, I'm going to set this to 1%. And we are going to close the options here. And we're going to go ahead and we're just going to convert one of these pieces here. So I'll start with the backrest right here. I'll create a piece and I'll convert this to ExactFlat, and we'll have a look at the mesh just to see what that looks like. I'm just going to use laminate for car seat here. And when we open up the Flattener, if we turn on our edge triangulation, we can see we have a very low polygon mesh. So if we close this and go back to our options, we're now going to go to the opposite extreme. We're going to go to 100%. And if I regenerate this mesh, this will just take a moment here, we can compare the two to see the effects of that quality slider. So now when we look at this mesh, we can see we have a mesh with many more triangles here. So this would be more ideal for use with the remesher. If we were to remesh this, we'd probably get a pretty good result. So we strongly recommend to use automatic tolerances. It's going to scale the size of your mesh relative to the size of your part, and it's going to save you a lot of work. Automatic pattern rebuild will turn on or off rebuilding of the pattern. So whenever we do something with the flattener, such as adjusting the using a pre-flattener or running the remesher, the uniform remesher, automatic pattern rebuild will automatically rebuild all your patterns downstream and update your markers to the shape of the new pattern piece. So we recommend leaving that turned on. If it's turned off, you're going to have to click the update button every single time you make a change in the Flattener window, and it's very easy to forget to do that. So we recommend just leaving that turned on. It's not a huge performance impact, and it's going to save you a lot of headaches with wondering why your patterns don't look correct. The other settings here are disabled whenever automatic tolerances are turned on. So if we turn off automatic tolerances, now we have access to all these settings, and this is where we can automatically adjust the minimum maximum facet width and curve core tolerance. If you set a maximum vertex count, this will kind of limit the number of vertices that can be created. However, it creates unpredictable meshes. You can't really predict where the sacrifices are going to be made to keep that vertex count. And the last option down here, target vertex count, if this is enabled, ExactFlat will generate a mesh using the SolidWorks meshing tools. If the target mesh count is much greater than the target, it will then generate a new mesh with lower settings. If that value is much lower than the target, it will generate a new mesh with higher settings. And it's a very iterative process. It will just creating meshes over and over again until we get close to this target vertex count. So it's not a very good method for creating a mesh. As the automatic tolerances is by far the best method. So we recommend leaving target vertex count off and just leave automatic tolerances on. Use legacy settings is an adjustment for the automatic tolerances. This is legacy settings is very good for developable surfaces or any kind of surface that is very cylindrical in shape. It will tend to produce very long, skinny triangles, high aspect ratio triangles that work extremely well for representing cylindrical and developable surfaces. So if you're working with developable surfaces, you might want to turn this option on, and that will actually create a better quality mesh for you. It kind of goes against our philosophy where we don't want high aspect ratio triangles, but for developable surfaces, we actually do want high aspect ratio triangles. They produce really, really good results with the pattern. So if you're working with developable surfaces, you can turn that on and you're going to get meshes that are a little better suited for the work that you're working. So we move down the initial flattening order. When we do any kind of operation in the flattener, when we convert to ExactFlat, or when we do any kind of remeshing operation, immediately following the remesher, we are automatically going to apply a pre-flattener to the result. And the pre-flatteners are applied in this order here. So the first pre-flattener that will be used is fracture. The results will be evaluated, and if there are any folds or wrinkles, we will then try stretch. The results of stretch will then be reanalyzed, and if there are any folds and wrinkles, we will then move on and try pelt. So all three of these pre-flatteners can potentially be used on the pattern piece in an attempt to remove any kinds of folds or wrinkles. If the results of fracture, for instance, do not produce folds or wrinkles, then the algorithm will simply stop and the fractured result will be used as is. So ExactFlat would use up to all three of these in this order in an attempt to try and produce an initial unoptimized 2D flat pattern that does not have folds or wrinkles. And you can change the order of these simply by selecting them and pressing the up or down arrows. That will allow you to change the order. So if you know that you're working with parts that are near developable, fracture is a very good first option. Stretch is usually a good second option, and pelt, it doesn't produce the patterns that are visually appealing. Usually they have the most visual distortion and strain. However, pelt is usually guaranteed to produce a pattern that does not have any kinds of folds or wrinkles. So it's a very good last option. Moving on to our optimization settings, this is where we can control the behavior of the pattern optimizer. First option here, preprocessor. This is more of a legacy option from when computer hardware was much more limited. ExactFlat was originally designed about 20 years ago, so CPUs weren't very fast, there wasn't a lot of RAM. And so preprocess is an option that will do a lot of upfront calculations. And store those calculations in memory as a lookup table during the optimization process. The reason there's an option to turn it off is because if your computer didn't have enough RAM, then you weren't able to use the option. But nowadays, every computer has plenty of RAM. CPUs are very fast, so there's no reason to turn that off. Just leave it turned on. It's going to speed up the performance of the optimizer. Allow Newton steps and allow quadratic steps are additional metrics that kick in during the optimization process. There's really no downside to having them turned on other than they may take a little bit longer. But again, with modern computing hardware, the performance difference or the performance impact is negligible. If they're turned off, your pattern might not look quite as nice. But if they're turned on, they may improve the quality or the fidelity of your pattern with minimal performance impact. Rigid differential is another algorithm that will kick in, and that will make an attempt to detect very long, narrow, skinny surfaces. And with this turned off, ExactFlat has a tendency to introduce a slight curve to those surfaces. So if you're flattening, let's say, like a steering wheel or something where that's flattened as typically a strip, a rectangular strip of material, ExactFlat will have a tendency to introduce a curve into the pattern. With rigid differential turned on, that will help mitigate that effect and ensure that your pattern that should be a rectangle will be flattened more as a rectangular strip of material. So it's recommended to always leave this turned on. You're just going to see much better quality patterns. It helps preserve symmetry and all that kind of stuff. Our last option here, no seam stretch. This will enforce a constraint such that the perimeter length of the 2D pattern piece must be the same as the perimeter length of the 3D model piece. So with that turned on, it does operate based off of a tolerance here. ExactFlat will always meet or exceed this tolerance here. So the default, I believe, is 10 millimeters, which means that when this option is turned on, ExactFlat will try to ensure at the bare minimum that the perimeter length of the 2D pattern piece is at most 10 millimeters more or less than the perimeter length of the 3D model piece. Usually ExactFlat will far exceed that value, and your difference is going to be closer to zero. So if you need to ensure that your perimeter lengths are always exactly the same, if no stretching at all is permitted, then you can turn that option on. And we recommend starting at the default 10 millimeter. If you're finding the deviation is still too great, then what you can do is come back and slowly reduce this value. You never want to set it to zero. You never want to just set it to a very, very small number. You always want to make small changes. So I would recommend if you're starting at 10, then maybe cut it down to 5. Then if that's still too much, then 4, then 3, then 2, and so on. If you get too aggressive with your no seam stretch tolerance, your pattern edge may actually start to look more like crocodile teeth, where it has a kind of a serrated saw blade appearance to it, and that's because ExactFlat can't resolve the strain, so it's artificially deforming the perimeter of the pattern piece just to meet the constraints. So make small adjustments. If you notice that you're starting to get edge deformation, then back off, raise the tolerances a bit. And if you're still finding that you have too much deviation, that's a good indication that you may need to introduce a cut into your part, or even a dart or a relief cut. Probably the best thing to do would be to split your pattern piece in half and try again, because there's probably a certain geometric feature in there that's just introducing too much strain. Moving on to the pattern tab. This is where we can adjust most of the defaults surrounding the seam and hem tools. The default edge type allows us to adjust the default seam or hem or bound edge that is automatically applied the first time we open up the seam or the hem tools. At this point, we should talk a little bit about global properties versus document properties. Most of the settings that we adjust in the ExactFlat options panel will adjust the global properties that are applied to every single new part that is created when we click the Convert to ExactFlat button. When we click the Convert to ExactFlat button, a lot of these options are copied to the document properties that are stored with the actual document. And when we start adjusting things in the seam and hem PMPs, we're actually adjusting the document properties. So if you make a change in here, it's not necessarily going to affect your document if you've already started your patterning work. These changes only are applied to new documents created when you click the Convert to ExactFlat button. So with that in mind, we can adjust the default seam for any new document by simply changing the value here. If we're not happy with 1/2 inch pinch, we can change that to, for instance, a 6 millimeter join. Same thing here, we can adjust our default hem to whatever we want. We'll pick 2 inches there. And if we had bound edges in our database, we'd be able to pick a default bound edge. Similarly, we can adjust the default notch chain setting. So if we always want notch chain, we can turn that on. We can adjust the type of notch that is automatically created. We'll pick 4 millimeter slit. And we can adjust the method that is used to create our notch chains. So if we want a set number of notches, leave it at count. If we want them at an interval, set it to spacing and adjust your counts of spacings. So we scroll down, we have our default hardware and markings. So this is the same as seams and hems. We can just adjust our default hardware and markings. Right now it's set to button. And for marking, it's set to general marking. I might want to change that to sew line, or whatever one is best for your organization that you're using the most. Lastly, we have our default notch. So this does not apply to notch chain. This default is for this tool right here. For precision notches, we can adjust our default notch type right here. When we send our patterns to the nesting, manual nesting or automatic nesting, Nesting is always done as polylines, so we do take the spline or curve boundaries of the planar surface and we tessellate those into polylines, and that tessellation is done according to these parameters here. You can adjust the chord tolerance. This is the maximum allowed distance between the curve and the midpoint of any resulting polyline segment of your polyline. And we can adjust the minimum line length. So this would be the minimum length of any segment on the polyline. So when we create a polyline, we're going to constrain the polyline so it meets all of these parameters here. When we create a drawing from our part, we can adjust the size of the symbols used to represent the different notches on the drawing by adjusting these parameters here. So if you'll recall, when we created our drawing, all of our notches were represented by circular symbols on the part. We can adjust the relative size of those symbols by changing the pixel size here. And when we print the drawing out, we can adjust the size of the symbol on the printout by adjusting our symbol print size. Our next configurations are the grain lines, and this is where we can adjust the default behavior of the ExactFlat grain line. Unless we explicitly set a grain line using the grain lines tool, ExactFlat has to do something to automatically create an automatic grain line for us. The default behavior is to use the current horizontal axis. So we're not in our pattern view right now, but if we were to go to pattern view right here, we can see our red x-axis right now, and with current horizontal x-axis set as a grain line mode, it's going to project this red line onto the pattern piece, and that will become the grain line. So now if we go to view markers, we can see our grain line. We can see our pattern piece in the exact same orientation as it is there, and we can see our grain line, the x-axis that we're projected on. The other option is, scroll down, use initial horizontal axis. So with this option, again, the x-axis is projected onto the pattern pieces immediately after conversion, but that grain line is locked into place. As you rotate your pieces, the grain line rotates with the pattern pieces. This differs from current horizontal axis in the sense where with this option here, the grain line is floating. So even though, if we, again, we'll look at markers here, we can see our grain line is perfectly horizontal. If I were to now rotate this piece using the Move Pieces tool here, so we've rotated that piece quite a bit. If we look at the view markers again, our grain line is still the x-axis. So with this mode, you can rotate your pattern pieces and you can align the grain line so it's the pattern pieces lined up so the grain line is always going to be projected on as the x-axis. It makes it a little bit easier to control the orientation of your grain line. Ultimately, though, the most control is given by the grain line tool here. However, we do strongly recommend that if you're going to use this tool, it has to be the very last operation that you apply. Otherwise, it will introduce instabilities into the workflow. Moving on, one of the features of ExactFlat allows us to apply edge labels within the seam allowance of our parts, and we can adjust the defaults for those edge labels using these settings here. So they're turned off by default. If you do want edge labels, then you can configure them here. And what happens is when we create a seam, these edge labels are copied over to that seam. So each seam has its own unique set of edge labels. So we're just adjusting the default settings that will be copied over. If you want them on, click this button to turn them on. Then you can configure your edge label. And every single time we create a seam, they will be copied over to that seam. The last option here is the export dialog setting. So this is, again, a specialty setting for when we click the export pattern button. What that's going to do is it's going to save our part as a new SolidWorks part file. It's going to append this suffix to the file name. And then if this option is turned on, the export settings dialog will appear. This is a very specialty tool designed for the pool and spa industry. And the primary goal of this setting is when we click the export button here, it's going to first save it as a new part file, and then we get this settings dialog here. From here, we can turn on panelization, so we can split up our panel into thin strips of material, and we have some controls for automating the downstream process of converting to ExactFlat, choosing our material that's automatically applied, how we want our pieces to be ordered on the document, and so on. So it's a specialty tool for the pool and spa industry. So we can turn on or off whether this setting is controlled with that option. So we'll close this. We'll go back to, actually we're going to reopen our share file. Okay, so moving on, we have our markers tab. And from the markers tab, we can adjust a lot of the default behavior of the markers and how markers are created. When we click the Convert to ExactFlat button, the default behavior is for ExactFlat to do the initial flattening. We then ask you to pick a material, and as soon as you pick a material, ExactFlat will automatically create a marker set. It will automatically add one marker for every single material selected, and then it will add all of the pattern pieces to the correct marker. So ExactFlat does a lot of automation in regards to helping you create your markers. You can turn these automations off. So if you don't want ExactFlat to automatically place your pieces onto the marker, you can turn off the auto place marker pieces on marker option. If you don't want ExactFlat to automatically create a marker for you when you assign materials, you can turn off the auto create markers on marker set creation. If you don't want ExactFlat to create a marker when you assign a material, turn off the first one here, auto create markers on material assignment. And if you don't want ExactFlat to automatically create a new marker set or a new marker when you create a new marker set, then you can turn off the second option here, auto create markers on marker set creation. You can have multiple marker sets. ExactFlat is configured where you have a marker set which contains multiple markers. This allows you to run different simulations on different types of markers, different materials, different quantities, and so on. And you can adjust the default marker set copy count from this parameter here. We recommend always leaving this set to 1 though. Reason being is you get more control. You can set the parent multiple in the marker controls, and that's a much better way to adjust the number of pattern pieces that are going to appear on your marker. When we are finished with the marker and we want to export our pattern as a DXF, we have to pick an export profile. And we can adjust the default export profile that is automatically selected by ExactFlat from the options panel here. So usually it's best to set this to your own cutting table type. So whatever your cutting table may be, if we have an autometrics cutter, we might set this to the autometrics profile, and that way when we click the export button in the marker interface, autometrics is automatically going to be selected. If we have any kind of text on our marker, we can set the height of that text using this parameter here. So this will control the height of the text that is exported to a DXF. Our last option down here, it controls the way pattern pieces are placed on the marker. The first option here, auto rotate piece to minimum height, will attempt to rotate the piece such that the width of the piece is at a maximum and the height is at a minimum. The reason we do the rotation is it increases the chances of the piece actually fitting onto the marker. If we look at our marker, it's usually a very long, thin strip of material. So it's best to orient the piece in that same orientation to maximize the chances that it's going to fit onto the marker. When doing manual nesting with the box packer too, this also tends to produce the best, most efficient nests, as additional pieces can be nested or packed on top of the first piece. It's worth noting that this rotation is only going to occur if the constraints of the piece lay rule or the piece constraints will allow it. So if your constraints are set to any way, any rotation is allowed, then auto rotate is guaranteed to work. However, if your constraints only allow 180 or 90 degree rotations, then auto rotate is not guaranteed to work. If the automatic rotation falls outside of the constraints, then the automatic rotation will fail, and your piece is going to appear exactly as you see it in your pattern view. Normally, pattern pieces are rotated in a counterclockwise direction to get them to fit the minimum width. However, we can adjust the directional tolerance here. So if we need, with the way this is set, it's set to 1/10 of a degree. So if we only need to rotate our pattern piece 1/10 of a degree in a clockwise orientation to get it to the minimum width, then clockwise orientation will be used instead. So if the required rotation in a clockwise direction is less than or equal to this value, then the pattern piece will be rotated in a clockwise orientation. Otherwise, it will be rotated counterclockwise to get it to fit onto the pattern, the marker. The implications are for this, there's always going to be two orientations that meet the minimum width, and if you rotate 180 degrees, you'll get basically a mirrored rotation. So you can control the default orientation with this. Collate bulk pieces on bulk placement. This is very similar to collation when you're printing your pattern pieces. In the typical workflow, when you add, let's say we have multiple pattern pieces on our document, if we add them all, it's going to add all copies of piece 1, then all copies of piece 2, then all copies of piece 3, and so on. If collate is turned on, it will add one copy of piece 1, then a copy of piece 2, then a copy of piece 3, then it will add the second copy of piece 1, the second copy of piece 2, the second copy of piece 3, and so on. So if you want collation, turn that on. If you don't want it, leave it off. And again, these settings are more for manual nesting. If you're using automatic nesting, Fraunhofer is going to take over and just re-nest your marker for you anyways. The default placement is set to none, and to show this off, what I'm going to do is I'm actually going to cancel here. And I'm just going to go ahead, I'm going to create some pieces first so we can have a look at the what a normal marker would look like. So I'm just going to create some pieces here. I'm using a default names, and I'm just quickly creating a marker for us. So we'll select all those pieces there, and we'll make sure we get all these pieces there. We'll quickly convert to ExactFlat here. And I'm just going to run through these steps really quick, and we'll come back once it's done. So I'm just quickly arranging our pattern here, just so we can really explore the effects of the default placement options. Okay, so we have our pattern, we have it arranged, and the first option we are going to look at, if we come back to markers here, is the piecement placement method none. So these options here, they affect the global defaults applied that are copied over to any new document when we click the convert to ExactFlat button. So adjusting these methods here, the placement method here, is not going to have any effect on marker for this document here because I've already converted it. These settings have been copied over to the document. So these simply affect the global defaults. However, we can adjust these on a per marker basis, and we'll have a look at that next. So we're going to leave the ExactFlat options now. We're going to go to the marker view. We have all of these exact same settings in the marker view, and we're going to examine these settings from within the marker view. So over in view markers, we can see that our marker looks exactly the same as our pattern environment. And that's because the piece placement method is set to none. If we change this to box packing, for instance, and we repack our marker, ExactFlat is going to make an attempt to automatically rotate our pieces to the minimum height, if possible, and place our pieces onto the marker. So we can see that we're making a very simple, primitive attempt at nesting our markers, our pieces together. The next option, linear left to right, does pretty much exactly what it sounds. It just arrays our pieces from left to right across the marker. Right to left will do the exact same thing, but just in reversed order. And then there's our last two options, salvage left to right and salvage right to left. They're just specialty options designed for the pool and spa industry, and their goal is to handle very small pieces a little bit differently. But probably the most two useful ones are none and box packing. If you're using automatic nesting, I typically leave this at none. If your goal is to export the DXF and nest it elsewhere, it's best to leave it set to none. That way your pattern pieces are in a recognizable format, and your nesting software can just pick them up and rearrange them however it wants. The other two options, linear placement alignment, this defines where our pattern pieces are going. So we're looking at a left to right alignment here, and our placement alignment was set to middle. If I set this to top, it's going to array our pieces across the top of the marker. If I set this to bottom, it's going to array them across the bottom of the marker. And then our last option, placement failure behavior. This defines where pieces are going to be placed if they cannot be rotated within the constraints of the material, the lay rule, to get them to fit onto the marker. So if we were to automatically adjust and manipulate, if our material wasn't wide enough to accommodate these pieces, then we can adjust where they go. Do not place will simply not place them on the marker. They will remain in inventory down here. So that's not the recommended method, because it's unless you're very careful and meticulous about checking your piece quantities, it's very easy to miss a piece that has not been added to the marker, especially if you have a very, very large marker. The other option, place at origin, it will just place every single piece on the origin. Again, that's not the most recommended method because it may be difficult to see how many pieces are there. But our last option, place above marker, it will array the pieces across the top of the marker in a very visible, very easy to see fashion. So this is the recommended option here, place above marker. So we're going to leave the marker now. We're going to go back to the options. And that's it for the marker options. Our next tab is costing. And this is where we can adjust the currency used for basic costing. So if you have ExactFlat Professional, you can set your default output currency here. So if you always want your reports in US dollars, you can set this to US dollars from the list. There. Our database tab, this is where we can set the default database used by ExactFlat. If you have multiple databases installed, you can pick which one is the default. That's always going to be used when you click the Convert to ExactFlat button. If your database is a shared database, such as a shared SQL Server database, then you can optionally turn on the Refresh Database on Startup option, and this will make an attempt to synchronize your local copy of the database with the remote database whenever you start up ExactFlat. If you are using Production Manager, you can set some of the default preferences used by Production Manager here, such as default site, default currency, and default unit system. The unit preferences, you can't adjust these. These are just previews for the unit system here. So if I change my unit system, we're going to see all these units updating to basically show us what our different dimensions are going to be measured in. Lastly, we have our database log entry option. With this turned on, whenever we make a change in the ExactFlat database, we are going to be asked to log the change, both your name and description of the change. You can turn that off, and that will disable logging. ExactFlat will automatically generate a basic log with the date and time that the change was made, as well as the computer name that the change came from, but it will lack the reason for the change. So this is a personal preference for your organization. If you don't want logs to be created, you can turn that off. So our last tab here allows us to control the localization of ExactFlat. ExactFlat only really comes in English. However, if you did want to localize it to your own language, you can create your own language files and place them in the localizations directory, and then your new localization will appear in the list here. ExactFlat only ships with English, so in most cases there's no need to come in here. You don't need to change the localization. So that covers all the different tabs in the ExactFlat options. The last thing we're going to talk about are these buttons over here. So if you have multiple workstations in your organization and you want the same settings in use on every single workstation, you can configure the ExactFlat options once on a workstation, and then you can click the Export Add-in Options button. This will export your add-in options as a DXF, or an XML file. And you can then take that XML file to another workstation, and you can click the Import Add-in Options, and you can import those options, and that's a very easy way to pre-configure options on many workstations so they are all uniform. Similarly, if you have your databases all configured on one workstation, if you have a shared database, for instance, you can simply click the Export Database Options button, and again, that will create an XML file with your database options, which you can then import on other workstations. So that's it for the ExactFlat options. Next, we're going to move on to the ExactFlat Database Manager. So as we create things like seams, all of our seam types are, pick an edge first, all of these seam types are stored in a database, and we can modify these seam types using the ExactFlat Database Manager. The ExactFlat Database Manager is accessible through the Windows Start menu, so just click the Start button, and if you just start typing in Database Manager, usually it's the very first item in the list, so we'll open up the ExactFlat Database Manager, and we'll have a look at this. So, for default installation, we're only going to have one database here. It's going to be the sample database. However, if your organization is a large organization and has a shared database on a SQL server, you may have a second option here for your shared database. There's some basic things we can do to the databases from here. If you want to remove a database, you can click the Remove button, and that will remove the database from your list. If you want to create a new database, you can click the Create button, and this will launch the database creation wizard. A local database is a database that's stored on your computer. It's only accessible by you. Other users on your computer do not have access to that database. So all you do here is you just give it a name, click the Create button, and ExactFlat will create a new database. It will pre-populate that database with default data for seams, hems, materials, and so on. It's just a very fast, easy way to get started with a new database. The other option, SQL Server Shared, this will create a database on an actual SQL server. We strongly recommend that you create a new privileged user specifically for ExactFlat, and you use these credentials here. Some people simply use the administrative credentials, others use the database administrator. We recommend you create a new ExactFlat user with privileges that allow you to create a new database. So you'd enter in your SQL Server username, server password. You can use Windows authentication. We don't recommend it though. We recommend you use an SQL Server username password instead. But if you have Windows authentication set up, then you can use that. And then you give your database's properties. So you have to specify the instance name of your SQL server, and then this is the new database name that you're going to be creating. ExactFlat's automatically going to create an SQL user for that particular database, and you can specify what you want that username and password to be, and confirmation, of course. And just like with local database, when you click the Create button, ExactFlat is going to create a new database for you, pre-populated with all of the the template data of the ExactFlat standard database. Just like within the ExactFlat options, close my PNP here. So just like over here in database, we have our default database option here. We can also set this default from the database manager. So we can simply select our database over here and click the set default, and this will apply the default flag to our selected database. If we already have a database in existence, but we just want to add it to our list here, we can click the add button, and this will add whatever values are down here to the list as the registered ExactFlat database. So if you're doing a backup or a restore, this is a good way to add this database to your list. So once we have our database created, we can then connect to our database simply by selecting any of our databases in the list. And if we click the Connect to the Database button, that will connect us to our database. Once we've been connected, we now have full access to our table editors and our management tools. We'll start with seams, hems, and bound edges. These are all defined in the Edge Features data table. So we can open up a data table either by selecting it from the list and clicking the Edit button, or we can just double click on the table and that will open it up as well. Once we are in the list, we have access to all of the different edge features. Seams, hems, bound edges, and raw edges, they are all considered edge features, and they share pretty much all of the same properties, so they are all in one table. As we scroll through the list, we can see all of our different properties here. We can see the name of the feature, the description, and most importantly, we can see the type of the feature. So the first ones here are all seams, and as we scroll down, we can see more hems, and we can see custom seams that have been added down at the bottom here. If we want to remove a seam type, we can simply right-click on the row or click on the row and press the delete key on your keyboard, and that will remove that seam type from the table. If we want to add a new seam or hem type, we can do that just by clicking down here in the box with the little asterisks, and now we can start entering our new seam parameters. So if we wanted to do, say we wanted to create an asymmetrical seam where we have 5 millimeters on one side, 10 millimeters on the other, we can do that from here, and all we have to do is give it a name and description. So we might want to call this 510. This is going to be created as a seam. Over here for our first allowance, we'll set 5. For a second allowance, we will set 10. We'll make sure we set our units. So this is millimeters. We are going to leave the symmetric flag unchecked. We want this to be created as an asymmetrical seam. If the symmetric flag is checked, it only ever uses the first allowance, but if it's an asymmetrical seam, it will apply the allowance 1 to the left and allowance 2 to the right. And then lastly, we set our default end condition, trim extend, and our default color, pick line. And now when we click save, make sure we pick seam, and now we can click save, enter in our reason for the change, and click OK. Now, any new part that we create using the sample database here will be, we'll have the ability to pick that new custom seam type from the list, and anyone who wants to use that seam type can use it. Marking features is where we can add new markings. So when we start creating our hardware and markings, the marking feature here, this is where all of our different marking types are. These don't change the way ExactFlat exports anything to a DXF. They are simply here for drawing tool purposes. If you apply or if you create a marking table, then the marking type can optionally be included as part of that table to help you identify what your different marking types are. Material Layrules. These adjust the allowable rotations of our pattern pieces on a marker. So these are the different sets of constraints. So each material has a lay rule, and a lay rule is a named collection of piece constraints. So from our lay rule, we have our rotation tolerance, our rotation increment, Whether the material is double-sided or not. We can turn on or off, allowing in the flipping in the X or Y direction. So if your material doesn't have a nap or a finished and unfinished side, then you may optionally turn on flipping, allow flipping X and Y for more efficient nest. We can also adjust the default edge buffer and the default piece gap, as well as their units from here. So just like with the edge features, we can delete any of them just by selecting the row and pressing the delete key, or we can add a new lay rule by filling out all the information in the row at the very bottom with the asterisk. Notch type is our last data table. From here, we can adjust the different notches included in ExactFlat. You can't create new geometry types. You have to use the geometry types that ExactFlat provides. However, you can modify the default width and the default depth of the notch to make their dimensions more compatible with your project. And just like with edge features, marking features, and lay rules, you can remove a notch feature by selecting the row, clicking the delete key, or you can add a new one by scrolling down to the bottom, the very last row with the asterisk, and entering in your parameters. Moving on to the management tools. The first management tool is the hardware category manager. So when we go to add hardware, there's a lot of different hardware types, and they are organized into categories. So from here, we can add new categories, and we can drag and drop different hardware types into the different categories. So this is very much a drag and drop operation. So if we wanted to move, for instance, the J hook into the buttons category, we just drag and drop that into the buttons category, and now J hook appears. When you're done, click the Save button, and that will save your changes to the database. As for the actual hardware types, that's controlled through the hardware type editor. And from here, this one looks very much just like a data table. We can just scroll up and down. And this is managed exactly like a data table. This is where all our different hardware types are. We can change the name, description, reference geometry. So some hardware types, like ISO buttons, you typically measure those in terms of quantity or the number of buttons. So they're typically represented by point entities. So that's why our reference geometry type is set to simple point. Whereas something like an elastic, you might measure that more in length, so meters. So for things like simple elastic, we measure that as simple line. Our options here are simple point, simple line, mated point, and mated line. With mated, it's simply going to cut your quantity in half, recognizing that you may have a mated quantity in there. You might have 2 points representing each half of the object. The last option down here, block. If you use sketch blocks to represent your different hardware types, so for instance, if you have some kind of buckle assembly, you might have a sketch block that represents the buckle. And block will set it so instead of measuring the length of the segments or counting the number of points in that block, it's just going to count the number of block instances as point objects instead. So you can set it to block if you're using sketch blocks to represent your different hardware types. And then lastly, we have color, and the other settings are more for information purposes only. Item number, site, default cost. If you're using basic costing, you can set the default cost of your hardware item here in its currency, and that will go in through our costing system. And just like with the other data tables, if you want to remove a data type, just select the row, press delete. If you want to add one, scroll down to the bottom of the row with the asterisk, enter in your parameters, and then you can click the Save button to save your changes. The Material Manager, this is where we can add different materials to ExactFlat. So when we open up the Material Manager, it's divided into 3 different columns. We have our categories on the left, we have our materials in the middle, and then we have our properties on the right. So we can add or remove different categories by clicking the Add and Remove button over here on the left. This will either add a new category to the list, which we can drag and drop however we want. Or we can select a category, we can click the remove button, and that will remove that category. We can select the different categories, and we can drag and drop our different materials into those categories. We can also drag and drop materials over here in the category tree. Similar to categories, if we want to add a new material, we click the add button. That will insert a new material into the material manager. And if we want to remove a material, we just select the material from the list and click the remove button, and that will remove that material from the list. On the right hand side, we have our properties. So for every single material, we have basic properties such as our general properties, name, description. You can enter in item number, site, default cost, and so on. Most of these are just for information purposes only. The cost will be used by our basic costing if you are using ExactFlat Professional. So you can enter in your cost and the currency that you use to pay for that particular material. Nesting is where we can modify the settings associated with nesting. So we have default width and max length. And the way we define whether this material is using bound surfaces or not is whether we have a max length defined. If our material has a max length set, then by default ExactFlat will be configured to use bound surfaces. If we leave this empty, then ExactFlat will be configured to use an infinite length marker. It will turn off bound surfaces. And of course, we can change the default units for those measurements. Below that, we can set the lay rule for the material. So all we do here is we just pick the lay rule. So if we change this to one way, we can see the constraints that are in play here. We can't actually change any of these. These are just preview items to show us what this lay rule is comprised of. So one-way rotation does not allow any rotation at all. Two-way is only allowing rotations in 180-degree increments. Four-way is allowing rotations in 90-degree increments, and so on. So you can choose the lay rule that you want to apply to your mesh. ExactFlat doesn't actually use the XY origin offset or repeats, so we don't recommend changing these, just leave them blank. Otherwise, you may experience unexpected results. Moving over to physical properties, this is where we store the physical properties that are used by ExactFlat. So ExactFlat does maintain a separate list of physical properties, and this list is separate from our actual material properties over here. The reason being is we might have 5 or 10 different variations of cotton where the material is exactly the same, but the only difference is the color of the cotton. So you might have white cotton, red, blue, green, yellow, orange, and so on. The material properties for all those different colors of cotton are exactly the same, but the only difference would be your inventory item number to match the color. So for those cottons, you'd have them measured once. You'd create one single set of physical properties here, and then for all 10 different colors of cotton, you'd choose the exact same set of physical properties. If you have a new material that you've just had tested and you want to add it to the database, you can click the New button here, and this will insert a new set of physical properties into this list, and then you can modify all the parameters for that set of physical properties. The report that you receive back is very explicitly going to tell you the Young's modulus X, Y, and bias right at the top of the report. Just simply copy those values into this database manager here. Make sure you set your material thickness and thickness units. And then down here, make sure you set your metric to linear isotropic. Once you've done that, you can then go ahead and click the Save button, and that will create a new material. Our last tab, Special Properties. These aren't used by ExactFlat. These are simply for informational purposes only. If you want to add a custom property to this material, perhaps you want to include the vendor contact information, you can do that using the special property. But again, these aren't actually used by anything in ExactFlat. Once you've finished making changes or creating your material, click the Save button, and this will update the database with the changes you've made. Our next manager is the costing manager. This is where we can adjust our currencies. So from here, we have a list of all the different currencies supported by ExactFlat, so you can adjust the relative conversion factor from one currency to another. Our next tab is the hardware costs. This is where we can adjust the cost associated with all of our hardware items. And then our last tab is the fabric costs. This is where we can adjust the cost associated with all of our fabrics. Our export profile manager is where we control the export profiles used for generating DXF files. On the left, we have our list of export profiles. From here, we can add new profiles, we can remove the selected profile, or we can clone the selected profile. In the middle, we have our basic profile properties. So we can adjust the name of the profile. We can adjust what type of file it's going to export as. We recommend leaving it at DXF. HPGL produces unpredictable results. So we recommend leaving it at DXF. ASTM is only recommended for use with our pre-built ASTM profile. This will modify the way the DXF is created to make it more compatible with ASTM export standards. However, we don't recommend using this because you will get unpredictable results. Our last two options here, per instance block definitions, will create one unique block definition for every single copy of a pattern piece. So normally, if we had 10 different pieces, we would have 10 different block definitions. And if we had 5 copies of each piece, then we would have that block inserted into the DXF 5 times. With per instance block definitions, we will create 5 block definitions for each pattern piece, and we will insert each of those unique block definitions once. So this is a compatibility option. Some cutting tables want a separate block instance for every single pattern piece. Other cutting tables want just insert entities. So depending on your cutting table needs, you may turn this off. Eastman Easy Cut, for instance, really wants a single block definition for every single pattern piece. So it recognizes, it reads all your pattern pieces in on a per block basis. The last option, no block definitions. If your cutting table does not recognize block definitions whatsoever, you can click that, and it's just going to export your DXF as simple entities with no block definitions. So the implication there is your pattern pieces will not be grouped together into blocks on your DXF. And then lastly, we can give a description for the profile. Over on the right-hand side, this is where our export entities are. We have a basic filter at the top so that we can use to filter our different entities. We're not necessarily turning them on or off with the filter, we're just filtering them from our view here. So we'll leave this set to all. We have a number of different entities that can potentially be included in a DXF when we export our DXF. We don't have to include all of them, and you can export only what you need. So right now we are looking at the Eastman Easy Cut profile. We are exporting the pattern perimeter and the internal perimeters. We are exporting the sew line. We are exporting piece labels, marking points, lines, and text. Grain line, we are exporting all of our notch lines and so on. And if we scroll to the bottom, we're going to see that we're exporting our hardware points, lines, text, our label lines, as well as all the annotations. So this might be too much. You might not want to see your labels. If you really like the profile, but you just don't want to see the labels, you can simply turn off labels, and then when you create your DXF, you're not going to see the piece labels anymore. Similarly, if you export your DXF and you know you've placed hardware on it, but you don't see any hardware in the DXF, simply scroll down to where hardware is and make sure that the hardware is turned on. If it's off, just place a check mark beside it, save your profile, and then the next time you export your DXF, your hardware will be included in the DXF. The most important thing to change with your profile is the layer name and the color. Primarily, the layer name is what's used by cutting table software to assign tools to your DXF. So when you import your DXF, your cutting table software is going to look at the different layer tables and it's going to assign a tool to the layer tables. So anything on the Cut Me layer is typically going to be assigned a blade tool, probably a wheel cutter or a drag blade. And that's how your cutting table recognizes what parts of your pattern are to be, how to treat different parts of your pattern. Once you've finished modifying your profiles, you can click the Done button. That is effectively a save button, and that will save your changes to the database, and then you can make use of your profile. The Auto Create Sketch Manager is a specialty tool created for the pool and spa industry. We're not going to cover this because it requires very special preparation of your parts. You need to add very specific custom properties to your surface bodies before you convert them to ExactFlat. So we're not going to cover this. It's a specialty tool for the pool and spa industry for some very specific integrations that we've done for them. Lastly, we have our version information here. This is where you can see your database version, and if you are using our production manager on a shared database, you can see your standalone table or your standalone table versions from here as well. So that's it for the ExactFlat database manager, and that's about it for the ExactFlat workflow. So we've got our part over here. When we're all done our patterning, if we want to export this to a database for use with ExactFlat standalone or production manager, we can do that from within SolidWorks. And when we export our part to a database, we are taking our saved part here, our pattern that we see in view markers here. We are taking this pattern, this nest, we are exporting that to a database. We can then use ExactFlat standalone or production manager to nest multiple parts together on the exact same material for a more efficient nest. So the first step is to actually export your part to a database. So when we are ready to export our marker to a database for use with ExactFlat standalone, we can do that just by clicking the Export Pieces button here. This is going to open up the export properties. And all we do is click the Export button, and that will export a new revision of our part to the database for use with ExactFlat standalone. Once our part has been exported, we can then start up ExactFlat standalone. It is accessible from the Windows Start menu. Usually if you start typing standalone, it's the first item in the list. Let's go ahead and click on standalone, and that will open up the application. First thing we're going to do is click the Markers and Nesting button, and this will bring us into the marker interface. When we exported our part to the database, it was exported as a marker set. So we are going to click the Marker Sets button, and from here we can create new marker sets. Every time we export a marker set, it shows up in the list here. So the last item here is our chair file, and we can see our different revisions that have been exported to the database. If we want to create a new marker set that combines multiple parts, we click the Add button here. This will create a new marker set. We will give our marker set a name. And now we can import different parts into our marker set by clicking the Import Part button. We will first pick our chair. And we have a couple other parts here. We're going to pick our automotive seat file. And we are also going to pick our automotive headrest file. All three of these parts were created using the leather material, so they will all be combined onto a single marker. Once we have imported all of our parts, we can click the Done button to save our changes and switch over to Marker View. Now we are in Marker View. We can see we have one single leather marker. Over here in our piece filter, we can see we have our pieces for our three different parts. And in our piece list, we can see we have our headrest pieces, followed by our car seat pieces, followed by our chair pieces. The most useful way to use Production Manager is to change the grouping options from no group to group by part. And this will color code all the pieces for each part as a unique color. From here, all the operations are exactly the same as ExactFlat for SolidWorks. We can start up automatic nesting by clicking the Nest button here. We can adjust our piece constraints over here. So if we wanted to add multiple copies of each piece, we can do so. We will add 10 copies of each piece. Now we can add all of our pieces to the document. And now we can do automatic nesting with Fraunhofer. We'll keep our max runtime at 1 minute. And when we click the Nest button, very quickly Fraunhofer is going to take over and start nesting all of our pieces together. Because we grouped our pieces by part, we can see that they are also being nested as grouped parts. So all of our headrest pieces are being nested up front, followed by our car seat pieces. And lastly, our chair pieces are being grouped in the rear. Once nesting has finished, we can accept our changes. And then we can export our nest as a DXF. And that's it for Production Manager.